scheduled for this first talk, but she is sick, so we have to skip this talk. And we start now with overview of data-driven hazard detection technology research at the WSU Disaster Resilience Analytics Center. This talk is presented by Professor Atri Dutra. He is the head of this Disaster Resilience Analytics Center, and I welcome him, and he will speak from the US over the stream. And now I would like to ask you to switch the signal.
Thank you. Is my screen visible?
Yes.
Okay.
Thank you very much. I know the time in your time zone is not as nice as the time in our time zone, so thank you very much for coming by. And the stage is yours.
Yeah. Good morning, everybody. We are just 7 hours behind, so but it's interesting, and it's a great opportunity for me to be able to present some of the research that we are currently doing at Disaster Resilience Analytics Center at Wichita State University. And as the title suggests, overview of data-driven hazard detection technology research at WSU's DRAC for enhancing community resilience. So it will be mostly an overview of some of the projects that we are working on. And there are a couple of more detailed, in-depth technical talks that will follow in the afternoon session, which will talk about a couple of these projects in a little bit more in-depth, detailed manner. So moving on, to give you a little bit of background on what DRAC is. So our group is kind of as old as the pandemic is, so roughly around 2020. There were these 4 different convergent science initiatives at Wichita State University in Kansas. So one of those were our group, which focused on disaster resilience analysis. And we have a team of faculty, more than 15 faculty across multiple different colleges, applied studies, business, engineering, liberal arts and sciences, and even we have a few faculty from the university libraries who are engaged in this particular project. The main focus is to look at this resilience of communities in the Great Plains region, which is marked over in this map over here. So mostly Midwestern region of the U.S. Now, the main goal of our team is to create a platform so that we can contribute on 2 folds. One aspect is the prediction of disasters, and the second aspect is more focused on the resilience side. And when we grew as a team, so we are only like a couple of years old team. So when we grew as a team, the first year was mostly focused on looking at those 2 individual components separately. Like we had a prediction group, we had a resilience group, and they were kind of interacting, not interacting much between them, but kind of separately looking at the prediction of disaster problem and the resilience problem separately. But over the last year, what we have done is we're trying to merge these together and try to evolve as a more of a transdisciplinary group. So the focus is, of course, the communities, to provide a little bit of context, some of the disasters that affect the state of Kansas For instance, if you compare in the last 40 years or so, the severity and the number of wildfires in the state of Kansas has increased by more than 400%. If you So the state is also located in what is referred to as a tornado alley. So that's also a major concern. There are other concerns due to earthquake and flooding as well. So within this context, there are a variety of factors that affect community resilience. Um, and among all of these factors, what I'm going to focus on mostly is are the factors that relate to the knowledge of the disaster, um, pretty close to the event. So what kind of data that are available for before the event or at the onset of the event, so that you can potentially provide better knowledge to the communities in terms of um, the level of threat or level of severity of the problem that is communicated, and ensure that there is enough lead time for preparedness of a disaster, and then um, and then how to better do the disaster management. So there are quite a few other aspects of resilience that are currently being worked on within the group, but I'll not touch upon those. I will mainly focus on kind of merging the prediction side and how it addresses the disaster risk reduction and disaster response. So from that perspective, where does this data come from that tells us how a particular event is going to evolve over time? So there are a variety of different sensors that collect data about an ongoing event. This could be collected by sensors onboard an aircraft, could be from satellites. There are radars from on the ground, terrestrial network. Then there are sensors in the sea as well. And you can add, although it's not traditionally treated as a sensor, but you can treat the social media as a sensor as well. If there are some events that are happening that particularly in remote areas, so then some of the information that is available over the internet through different social media could potentially be used for better, efficient disaster management. And from that perspective, I would treat the social media as kind of a sensor data as well. Okay, so I'll give you, to put things into perspective, I will focus on one example of a disaster and see how all of these different data are typically combined in order to create a forecast. And then based on the forecast, the disaster evacuation plans and other plans that directly affect how the disaster management is being carried on at different communities. So that's that aspect I'll cover over this slide. So I already mentioned a variety of different sensors. So with respect to the hurricanes, if you look at the United States, all of these different sensor data are being collected. So NexRad is a set of ground-based radars. NOAA's Hurricane Hunters. So NOAA is the National Oceanic and Atmospheric Administration. So they have aircraft that fly close to the storm in order to collect data. Then there are satellites which operate around 36,000 kilometers above the surface of the Earth. These are the geostationary satellites that have pretty much a constant view over a particular surface or particular region of the Earth. and they take data monitoring that particular region. And more recently, you have fairly small satellites that can have sensors, miniaturized radars on board in order to collect some of the collect this data. Now, each of these sensors has its own pros and cons. For instance, the ground-based radars are limited by their range. They are mostly sensing closer to the coastal areas or when the hurricane is on the land. So remote areas are going to be inaccessible to these radars, and then aircraft only can do finite number of missions. So and if you look at the satellites in geostationary orbit, they are so far up they cannot really study the three-dimensional structure of the hurricane. So there are limitations associated with the variety of sensors. However, all of these data are collected and assimilated through a system called GDAS, or Global Data Assimilation System, that is used for the forecasting. And these forecasts are eventually disseminated to the various communities to prepare for that particular event and plan evacuations as necessary. Now, one of the challenges, even in today's world, is that in spite of the whole vast sensor network that we have, there are regions that are fairly data starved. So if you look at the spatial and temporal resolution of the sensor data, that do not often meet the needs for or the data needs for the forecasting systems. So often these forecasting systems they would use simulated data or data from the previous forecasts in order to be able to do the future forecasting. So, for instance, the Atlantic Whirlpool region where the hurricanes originate, they are hugely data starved. You don't have a lot of sensor data over that region. So if you would potentially increase the availability of sensors over there, you can improve prediction and prediction. And when I say prediction, it is not only the path of the hurricanes, which the current state of the art does fairly good job in terms of tracking the path of the hurricanes. It's the intensity of the hurricanes, where you have to know a lot about the three-dimensional structure or the vertical structure of the storms. That is where improvement can be done. And of course, if an event is happening right now within this formal context, there is, of course, limited formal mechanism to incorporate any social media data into what is when an event is happening, to incorporate within any of these disaster risk reduction or disaster management operations. So that's kind of has been the focus of some of these aspects of the research. And I'll go over briefly through some of the problems that we are looking at. For instance, we have a sensor placement problem where we are looking at historical data of the hurricanes and based on that designing the sensor network. But often what happens is that if you want to cover a region such as the Atlantic Whirlpool, in order to get better early prediction for the hurricanes, you are talking about potentially deploying more than 200 satellites in space. And these are small satellites and can be launched together, but that comes at a high infrastructure costs. So that's one of the aspects that needs to be dealt with, that who should be in charge of creating this infrastructure and potentially reducing the number of these sensor by what we are currently looking at, what we call targeted sensing. So providing communities where there is more need of sensor data collection because they are more vulnerable, you would probably, rather than trying to cover the entire region, you kind of divert your sensors to collect more data over those particular regions where you feel that the effect of the event is going to be more impactful. So the other aspects, in order to study the vertical structure of the hurricanes, we have been looking at what we call is the sensor cluster design using satellite formations, where if you are looking at fairly close, placing these sensors fairly close, you would be looking at differential measurements over a particular region that helps understanding the vertical structure and improving the prediction of the phenomenon. Then the problem three, and this has to relate with wildfire detection. We had been looking at using machine learning to detect or wildfire from satellite images. So in most cases, satellites are the first sensors um, that catch a wildfire. But if you can potentially do some of these computations on board using lightweight machine learning models, you might be able to um, catch the wildfire much earlier on, simply because often these low earth orbit satellites, they don't provide continuous coverage over a certain area, so they would have revisit times, and these revisit times over a particular region could be fairly large, and compared to the rate at which a wildfire might spread. So there is value in potentially being able to detect directly on board whether a wildfire exists from the satellite image itself. And there is a more in-depth talk in the afternoon where one of our students is going to present on this particular aspect of the problem, going into the technical details. And we have been also looking at potentially using different data learning models, analyzing social media, text, and images for unraveling better disaster-related information, and this will help in facilitating some of the disaster response operations. And again, we have a more in-depth talk on the machine learning models that have been used in order to do this analysis, where we show that combining text and image data has some value in terms of unraveling those information. We are currently working on this aspect of using satellite images in order to identify structural damage in buildings. So this is more of a post-disaster. So if you might be able to compare post-disaster images and pre-disaster images and come up with an estimate of how much damage has been, structural damage in buildings have happened due to a particular disaster. This is a work in progress. So that's kind of a recent work that we have started. And this is kind of the overview of the um, work that we are doing on the front of hazard detection. So one of our goals is to potentially look at or be able to quantify how some of these different technologies that are being developed, how they improve the resilience of different communities. Particularly, one of our interests is the targeted sensing idea, where we could potentially use sensors to provide more information to communities that are more vulnerable to a particular disaster. So with that, I will stop here. Here is some of our contact information, and I'll be happy to answer any questions that you might have.
Check. Okay. So, do you have questions? So, I have a question. It seems to me that you have a lot of results already based on your forecast that you can share with the community or the public. How is your strategy to give these forecast results to other stakeholders in order to reuse them in their processes? Is there something we can use, for example?
So Yeah, that's a good question. So within our community, we have been so our team, as I had mentioned, are only a couple of years old. So we have been trying to develop some relationships with, for instance, the fire management program of Kansas Forest Services to understand how the different training and outreach activities are done in the various communities related to wildfires so that we can better disseminate some of this knowledge that we are gaining to those communities. So we're kind of working towards that in terms of our outreach to the various communities. And with respect to the questions with respect to like collaborations with other groups, we are open to look at collaboration opportunities and uh, data that we are using, and some of the results that, if you are interested, we'll be happy to talk to you more in depth, maybe offline, to look at collaboration opportunities. If does that answer your question?
Yes, thank you. I have another question. So you mentioned this global data assimilation component in your talk. This is a little bit similar to what we are trying to do with knowledge graphs. So I'm interested in the technological basis for this component. Maybe it's comparable are you using ontologies, or how do you structure your knowledge about the disasters? So can you explain this a little bit more?
Yeah, so that's a good question. So this global data assimilation system, so I kind of quoted this as an example. So when we go over our project over here, so we are not actually doing the global data assimilation system. So this is part of kind of the state of the art facility at the NOAA, which is a governmental agency, National Oceanic and Atmospheric Administration. What we are really doing is this global data assimilation system has a particular expectation. For instance, it collects data on a daily basis over a 6-hour window. So it has over a particular geographical region. So we are trying to meet those particular constraints for the global data assimilation system when we design the sensor. So we did not actually design any of the aspects of the global data assimilation system. But if you're interested in combination of different data, particularly multimodal data, I think this particular talk would be that talks about um, image data and text data that might be more interesting, and that might provide you more information related that what your question was probably focused around. So multimodal data assimilation. Does that answer the question?
Yeah, you mean the talk from Mr. Kota, yeah?
Yeah. So yes.
Yes. Okay. Thank you very much. Are there any other questions in the room? No, seems not so. So I would like to thank you for the presentation. And I wish you a good night now.
Yeah. Thank you for the opportunity.
Okay, so we now continue with the next speaker, which is Dr. Arndt. Dr. Arndt is a link data expert a senior link data expert at Essenza. He got his PhD from the University of Leipzig, and he will present about the knowledge, the Koipu platform data integration workflow. You want this? Okay.
So, yeah. So I hope my voice works. This is sponsored by the Sensa Semantic Beer Garden. No, not only that. Okay. So I will speak about the Koipu platform and the data integration workflow. Yesterday, I presented the data platform already and gave you some insights in the possibilities with the data platform. But today we will focus more on the needs and the things we already did in the Koipu project. So this is an overview from our Koipu webpage where we show different aspects, the functional aspects and the artifacts of the Koipu platform. And I'm the lead of the AP2, which is concerned with the infrastructure and the software aspects. And I mainly focus, or I think my focus is mainly on this area. So we need to work on the vocabularies. We need to gather the data from the company. We need to gather background knowledge and then provide possibilities to interact with this data and build a knowledge graph from this data. So you've seen the slide yesterday already, and as we have heard yesterday, the slide is outdated. So we shouldn't subsequently go through the cycle, but as I see the situation in the project, we don't do that. We don't strictly adhere to the cycle, but we do the steps individually and in parallel at the same time. So we, just to recall the steps which we need to do, but which we don't need to do subsequently. We need to gather the data. We need to align the data with the vocabulary that we choose. We need to review the data and create data according to the mapping and review the data, work with the data, and iteratively extend the mappings of the data. So in this case, I want to show you a use case where we have gathered some geo-information, some data sets from the European Open Data Portal and geonames to create a foundational or reference data set for geo-information, which is very important so that you can locate the hazard events and all the other events to some location in the world or to some administrative areas or to whatever extent these events have an effect. So then we had to look at the vocabulary, and we already have some colleagues working very hard on the vocabulary, and I don't know where the other colleague is, but yeah. We have quite active people contributing to the vocabulary, but when I updated the vocabulary in the corporate memory, I realized we didn't yet publish it. So that's a to-do for us in the project, that we should definitely publish our vocabulary in our namespace so that we can make it available as linked data, and so that we can also benefit from all the cool vocabulary management technology which we have heard of yesterday, for instance. In the vocabulary, we already have classes like country and a lot of properties attached to this or with the domain. And now we want to transform our data. So here I show the mapping editor of the data integration tool of the data platform, of the corporate memory. And in the top, we select the class to which we want to link our new data set. And then we simply go through all of the individual columns of our source data set. So in this case, we had an XML data source and a CSV data source. And then we can go in the XML through the individual fields and align them with properties. And we can go through the individual columns of the CSV table and align them with properties. And we can also perform transformations on the data. So in this case, we built a URL for our countries, and we have decided that our URL schema is https data.koipu.org/country, and then we want to attach the ISO 31661 alpha 3 part, which is DEU, for instance, for Germany, not DE, but DEU, to make it distinguishable. And so here you see also our graphical mapping editor. And as you found out, for all the individual steps, we have support with graphical tools which allow us to go through the complete data integration process. We do not need to touch Turtle directly. We do not need to touch the command line, but we are able to do it if we want to and if we want to automate things. But you're also able to visually get an impression of what you're doing. So the result data, in this case, is for Germany. And so you can also explore the data. So you can see all of these steps that I've shown in the beginning are supported by the corporate memory tool. But you can also see it in Turtle. You can also write Spark queries. I don't have a screenshot for that. And of course, I forgot the linking in between. So after we have mapped the data to our target data model, we can also take the data, or even before we map it, we can take the data and perform linking tasks on that. In the project, we also had a workshop on that last week to get a deeper understanding in the whole consortium. But basically, the thing is that we have some source paths and some target paths, and we can compare them based on quite a bunch of comparisons, and do this also in parallel with other properties, and then join them with logical operators to decide on our linking score whether we want to link these entities, or create a link between these entities or not. So the complete workflow now looks like that. Actually, those are 3 workflows. The right workflow integrates the left 2 workflows and calls them here. And here you can also see that you can also get a visual impression of all the individual workflow steps that are performed to lift your data, to make it available in your knowledge graph in the end. So here we have our Koipu country and location knowledge graph dataset in the end. And all of these individual steps are steps like what I have shown before. So we have data sets as input, then we have a transformation that was this process, the transformation process, and then we have also again the data set. We can perform a query on it, data set, query, data set, query, data set, and here we have the data set, and then we perform the linking between these data sets here. So that's actually like zooming into this block here. So there's a visual language between the whole process. And as you've seen in the cycle model, again also our user journey, which I've also shown yesterday, which is underpinned by a lot of different tools that we provide, or different aspects of the corporate memory. And so from the raw data, we can get towards the integrated data via our knowledge graph, and we can select the data from the knowledge graph, and we can then also visualize the data. And we already have a lot of dashboards and a lot of people working with visualization in the project. And so I think the data integration the data integration tool helps us a lot to perform this process along with the data manager and of course the data platform. So the corporate memory helps us to be a hub for the data processing in the project, and it's also used very widely. And here you can also see our possibilities on the command line, so you can access this visually with your browser, but you can also access this on the command line with corporate memory control, which allows you to integrate these workflows, not just that you have to click on the play button to say, okay, I want to run this transformation, but you can also schedule it and integrate it in continuous integration processes. And here's a little bit future work and also current work slide from our for our project setup. So quite recently, we have discussed what kind of dataset catalog we want to use in the project. So as you can see, we work with a lot of raw source data, but also integrate a lot of data into integrated data sets on which we want to work. And we need to keep an overview on that and need to catalog this so that we can search for the data sets when we have a specific use case. And so we have set up the Corpus data bus, which is basically the software of the DBP data bus, along with the Leibniz data manager, which built our data cataloging infrastructure. And we already have an adapter, which is in very early prototype state to integrate corporate memory with the data bus. So you can consume data from the data bus directly in the corporate memory and publish in the future also data to the data bus. And in this way, we can use distributed instances of the corporate memory, so like internally inside our consortium to work on the data, but we could also provide part of the data as open data to other interested parties in our project results. So I think, so I took you on a journey through this, how we can lift data from background knowledge, in this case, to our knowledge graph. So thank you very much.
Thanks, Nathanael. Do you have a question to Nathanael? I mean, we are now working on the same topic for 1 year, so it's most likely difficult to ask new questions now, but and we have a lot of time in the session. So do you have a question? Because I have no question because he's my colleague. If not, then thank you very much for the talk, and we continue with the third and last speaker. So I have a question to the audience. We are now ahead of time. And does someone feels good enough to do his talk from the last session after Simon, who is the next? No, Norman is the next. Both, okay, yeah. Then he should come to me in the call now, in the talk now. Okay, so our next speaker are Simon and Norman from the Infi.
Verkettet. Sehr gut.
So,
yeah, that's already the background.
Both are working in the group of Michael Martin. Both are researchers and or PhD students. And the talk is the semantification of geospatial information. Yeah, thanks.
Thank you. Oh. I'm searching my cursor. To go to the left.
Yeah, I am Simon Bin, and next to me is Norman Radke from Infi, and we are just figuring out here the technical part of the slides and the dual screen, and now we can get started.
Yeah. So welcome to our talk, semantification of geospatial information for enriched knowledge representation in context of crisis informatics. Yeah. As Simon said, we are Simon and Norman from Infi here in Leipzig. And together with our co-authors, we are part of the Koipu project, and this is a part of the work we have done in the project so far. As Nathaniel said in the talk before, we use RDF to organize our knowledge. RDF can be considered the lingua franca of semantic integration, and Sparkle is the query language to go for if you want to get some facts out of your knowledge graph. Extending GeoSparkle allows new horizons in crisis and resiliency management, and our tools are free software, and so we encourage you to try them out. The tools are the RDF processing toolkit, which can be easily used on command line, Apache Jenna, and our extension module Jenna X, which adds additional features like Web API and JSON processing, and from the Open Geospatial Consortium, GeoSparkle. In our presentation, we want to show you a few things that you can practically do with our tools. One showcase is the querying of web APIs and geodata processing. You can choose between these approaches or combine them. The first one is to use APIs for live requests, and the second way is to integrate geodata in your knowledge graph. Of course, you have to deal with some advantages and disadvantages for each solution. So APIs on the one hand are up to date and easy to use, but you might have to deal with request limits or coarse granularity. Materialized geodata, on the other hand, can be linked with other existing concepts, but could be out of sync after some time. For example, the nominatim API does not contain geometries of motorways or autobahn, because it is more concerned with locating addresses. If we materialize the data ourselves, we can choose just exactly what kind of data we want to load. Let's have a look at the two approaches with help of an example. In our example, we want to visualize the Elbe River on a map. At first, the live consumption approach. In this example, we can see a Sparkle query using content of a Wikidata request. It's at the service clause. And reusing this information to create a URL of nominatim service, a web service API that returns JSON data. And holding the geo information then we were looking for, and in the last step, the raw result is casted to JSON, and we can see the river on a map. The second approach needs some data transformation tasks before the geodata is available in your knowledge graph. You can take CMEM or the processing toolkit to get to this goal. In this example, data from OpenStreetMap is transformed to RDF using a direct mapping. While the direct mapping does not follow the best RDF or OWL modeling practices, it has the advantage of being very quick without the need to define a schema, while still allowing to use the whole OpenStreetMap data easily from Sparkle. Now we can ask for this information using simple triple patterns for the river data in our Sparkle query and get the result we want. Due to the fine granular schema of data within the OpenStreetMap community, we need to reassemble many small fragments of a river back into a single geometry object. We can use the GeoSparkle functions, line merge and collect to do this. We continue to work with the example of the Elbe River and further expand it with other knowledge graphs that we have collected in our triple store. For example, a graph with railroad network, another graph with road network, and a graph with countries and administrative regions, like states, or a graph with company data and their locations. Then we could ask the question, through which administrative regions does the river flow? What major transportation infrastructure is nearby the river? What companies are nearby? And these are just some examples of what can be done when we have geographic information available in Sparkle, and that is more difficult to express with non-geographic Sparkle. Let's see how it looks.
Yeah, on this slide, we can see the River Elbe now from the example before, but we have linked it together with the railroad and road network and the administrative regions that we have stored in other knowledge graphs in our triple store. And for example, in the Kolpju project, we could envision some similar use case. For example, if we had data on a flooded region, then which roads may be blocked, or which companies might be affected, or maybe which state should provide the disaster relief. And let me also point out some very technical details here. When we want to calculate a buffer around the river to find entities nearby the river, then we need to be careful. If we want to do this in meters, this is not possible because of the world geodetic system is in degrees. So if we want to do it, then we have to choose a metric reference system and then convert the geometries back and forth so that we can calculate the buffer here. And I have just to illustrate these, I have always put some small excerpts from our Sparkle queries on the slide so that you can get a feeling how this is done in a technical way. So what you need to write there. Another Kolpju use case might be for disaster events. Maybe we could find companies that might be affected by earthquakes, for example. And here in this slide, in this example, we have again combined two approaches available in our tools. First, we have consumed a live feed provided by the US Geological Survey Department of Interior, which contains recent earthquakes and their impact boundaries. So we have drawn them then on the map, and we have matched it to company locations that are also stored in one of our knowledge graphs, and we have matched it with GeoSparkle using some circular nearby query. At the beginning of the talk, we have already introduced a mapping of OpenStreetMap data into RDF. And another common format that I want to show you here is the geography markup language. It's very often used with geodata, and GeoServer software is also very often used to host the map data, which can be exported as GML. And here we have an example how to transform this GML data into RDF by using the RDF processing toolkit. So you see here in the top right there is the XML document, and then there is a complicated looking SparkQL query, which then transforms this into a knowledge graph. And thanks to GeoSparkle, we can consume these GML geometries that are contained as fragments in this GML XML document. and then convert it into GeoSparkle geoliterals, which we then can use again in our queries. So you may be questioning why we should do this, and one example that we have shown here is if we have the GML map to RDF and also the OpenStreetMap data from before, then we can use this new knowledge graph and combine it with SparkQL and use it to, for example, to compare water ports in OpenStreetMap to some other water port data set that we have obtained from the World Food Program. And then we can do a comparison, like how many structures can be located in the one or the other data set. Or this could be used for many quality assurance, or we will also be able to use this infrastructure information as part of the Colpu project. As you may know, if you have worked with data before, there are also many pitfalls, and so I want to use the remainder of this talk to introduce you to some of them that we have encountered while working with this data. And one problem that we found was when initially when we wanted to consume this GML data in GeoSparkle, it just didn't work. Like we had only empty geometries, and in the end we traced this down to a wrong XML namespace being used in the GeoSparkle standard. And we have opened an issue about this, and so this is now fixed in the current version. Another issue that you need to be aware of is when extracting GML from a GeoServer. Normally you can give in the request, you can give a coordinate reference system that you would like to export the data. However, if the GeoServer does not know this reference system, then it may just respond with an invalid coordinate reference system in the XML document. So without like throwing an error or something, which makes then GeoSparkle unable to process the data properly. So the best solution here is to use the server-provided default coordinate reference system, and then transform it in SparkQL if you need to. And another issue may be that the size of the XML response from the GeoServer is just too big to load into a string. So you have to be careful that you use a streaming parser to process it. But of course we offer a streaming XML parser in our tools. Another quite interesting performance issue arose when we tried to geo-match all companies in our one knowledge graph, which are located in the United States. Because of the pre-filter, it uses like a bounding box envelope of the USA geometry. And there are like a few tiny uninhabited islands which are claimed by the US, so which you could think they should be basically to the west, but because of the coordinate system of the Earth being divided at one point, arbitrary point, they end up being to the very east. So the bounding box will then span nearly the whole Earth, including all of Russia and China, and the querying and matching of the companies becomes much more expensive than it should be. So it's, in this case, it's more efficient to break the US down into its smaller parts before doing the matching, which we also have some functions to explore the geometry in GeoSparkle to do this. But yeah, sometimes you have these kind of surprises, let's say. And if we want to find, for example, power lines in OpenStreetMap data, then we are also quickly overwhelmed of the huge amount of power lines that some crowd mapping people put on the map, like all the small power lines that are connected to each house and so on. But maybe these are not so much relevant for our Koipu project. We are maybe more interested in the big power line structures. So in this case, we may want to reduce the result set with some filters. One possibility to do this would be to check the voltage that is annotated on these power lines. For example, in the United Kingdom, the power stations, they produce electricity at 25,000 volts, and electricity is sent through the national grid at 400,000 to 132,000 volts. So maybe a good filter would be to check only for power lines with 100 to 400,000 volts in order to eliminate like the small power lines in the UK. And finally, I just want to summarize again our contributions to the Apache Jena framework. We are contributing batch services, GeoSparkle speedup and fixes, GeoJSON exporting, compressed file loading fixes, JSON streaming, and more. Then we have our extension module with SparkQL extensions, which are not like core standard enough to be put into an official semantic web framework, like remote API queries, and extended GeoSparkle support with collect, line merge, GeoJSON readers, simplify, latitude, longitude, centroid functions, and so on. Very useful for actually working with geographic information, and also JSON, CSV, XML, and so on parsing functionality, which can be loaded into Jena just by dropping a jar file in the extras folder, basically. Very, very simple. And our RDF processing toolkit, which is a command line tool where you can easily map other data sources into RDF by using SparkQL queries. It can work with in-memory graph models for temporary like mapping steps, intermediate steps where you need to calculate something, and it is also configurable with environment variables for its pipelines. And as part of the project, we have also experimented with Barra-Aus proxies to better integrate the Essenza CMEM platform, and some Python and Plotly and Sparkle and GeoJSON experiments which use our technology stack here to put these things on a map. Yeah, and that's it from us. So any questions? We are happy to answer.
Yeah, thank you very much. Impressive talk in terms of SparkQL features. So I've never seen so complicated GeoSparkle queries. Are there any questions from you, Nathanael?
How big is the GeoSparkle support in like other frameworks? Is it only Jena, or is there a wider availability of these features?
Yeah, so the GeoSparkle is a standard. It's not a core Sparkle feature, but it's a standard by the Open Geospatial Consortium. And also we have experimented a little bit, like Sebi has turned on the GeoSparkle support once for us in GraphDB, and so we did some initial experiments there as well, but we were a little bit underwhelmed with the performance and also with the support for some extra useful features. However, it's not conclusive, like it could be just because of the provisioning of the instance or something. We haven't done any in-depth research on that topic, yes. And also the newest version of the CMEM also allows to create the WKT literal data type. So I have already successfully transformed some data using CMEM, which will then have GeoSparkle properties, but I haven't been further investigating there on these. And I know also that Stardock as well has some geo functionality, but again, we have not done here an in-depth comparison, or so I can't say in detail how well the support is.
As far as I know, your next step is to provide a server on the hardware of Hightech. Is this correct?
There's some planning by Hightech and Ricardo to get such a server, but yeah, I hope we can do it, but I don't know if what the current status is for that, yeah. So that we can do more experiments. At the moment, we have for the OpenStreetMap, which is quite a huge crowdsourced data set, we have worked with some offline preprocessing to extract small parts of the OpenStreetMap data. For example, only power lines, or only major roads, or only water structures, and so on. And then have on our own, like, very small server, we have loaded these data sets to experiment with it. But we would be very interested also as part of a Klaus linked geodata project to load like a more complete view of the crowdsourced geographic world. And we hope to try this on the Hightech servers when they arrive.
Okay, Norman, Simon, thank you very much for the talk. And since no one opted for being earlier than he expected, we can close this session now. I think we have a lot of time to the next session, but since the coffee breaks are synchronized with the other event, we have start now our break 20 minutes early and start again at 11. Thank you very much.
Hello and welcome everybody back to the second session of this workshop. My name is Sabine Gründer-Fahrer from the Institute of Applied Informatics in Leipzig. I'm going to chair this session, and without further ado, let's start. The first speaker of this slot will be Siavash from the Center of Scalable Analytics from the Technical University in Dresden. The SCATS is a well-known big project, one of the 5 big competency centers in Germany that is focused on a wide variety of topics around big data analytics and artificial intelligence. In this particular talk, we're going to focus on the topic of monitoring systems via analysis of system logs, and more specific, the question will be whether such system logs, after having gone anonymization, are still considered a valuable source or basis for training standard AI algorithms.
So, hello, and thanks a lot for this nice introduction to the topic. My name is Siavash Bersfan. I'm coming from Technical University of Dresden. Unfortunately, Tom today was not able to join, so I took over. I hope to successfully do this presentation karaoke. As Sabine just said, this would be about assessing whether these anonymized system logs are useful for further training and use in the machine learning era or not. As usual, I will start to motivate the problem and then give you a short introduction about the parse, which is the anonymizer that we are using, and then the objectives of this talk. At the end, there will be some insights about the data that we collect, the methods that we provide, and some discussions about the final results. Good. To motivate the problem, now we know that all these modern computing systems are getting bigger and bigger, and understanding their behavior and monitoring their conditions is becoming a challenge. For that, we are using different types of data: temperature, power consumption, CPU workload, job submissions, and so on. And one of them are the system logs. When we are dealing with certain data, there might be a problem, and that comes from our concerns about the privacy. Because the system logs may hold some sensitive information among them, which are not that convenient to hand over to the other companies to process them for us, or even we cannot hold them for a longer period of time. Therefore, anonymization are there to address this challenge and cleanse the data before doing processing. But then comes another challenge. After anonymization, probably the data is not that useful anymore in compared to the original data. So this is what we want to tackle today. Assume such a pipeline. We have these system logs. They go through an anonymization process, and once we've done that anonymization, the data left over may not be useful for the further analysis. I mentioned system logs. System logs are now a de facto protocol on almost every computer on Earth, regardless of the underlying operating system. And it is regulated in this RFC 5424 protocol, so they are, to some extent, homogeneous. They are divided into 2 parts, the header and the message part. The header is quite easy to understand because it's structured. There are certain fields there which says when such an event happened, where that event happened, and so on. But the message part is the critical part. Because inside the message part, there might be some sensitive information, as I said, like the public keys, username, IP addresses, even software version, hardware information that probably we don't want to give away to the outsiders, or we are not allowed to keep them for a longer period of time, especially if it goes to the user's data. For that very reason, we created parse. What does parse doing here? Parse essentially takes the system logs and make them completely anonymized and then encode them in a way that they are not recoverable. So we cannot really re-identify them again after this anonymization phase. On the screen, you see 2 examples. There are 2 different entries. They are happening in 2 different timestamps, and for the sake of simplicity, I removed all the other parts of the header. They are not relevant here. We have only the location and the timestamp and the message part. These 2 messages are different. However, if you look closer, you see that they are reporting the same event. Although different users are doing that, and they are happening on different file passes, but the event itself is the same. So what we can do here is clustering these system logs based on their similarity, and then trying to identify the variant part and the invariant part, the constant part of these messages. As we do so, we can replace those variants with some constant values. And then the granularity is in our hand. For this particular presentation, we would took the lowest existing one. So I would replace all the usernames with one single constant. In this case, it would be USR_. And then all the passes will be simply replaced with pass. Once we do that, if we use a good collision-resistant hash function, we would end up to having different hashes, which are identical in the sense that keeps the similarity of the messages. So as we see here, the final hash keys, which are shown highlighted in yellowish color, they are identical. So although they are completely anonymized and they are encoded, I can still see the similarity between them. So what happens is at the end like this. We have so many text messages. In this case, consider rows 1 to 4 and then row 9 to 16. All of them are carrying similar information. They are not identical, but they are carrying similar information. And then as we see, the category ID, which is essentially this hash key, are identical. So this part, we don't care anymore. We just get the sequence of the data, the timestamp, and the categories. And with this information, we go to the next stage. And of course, this is quite safe to share this information, to store this information. Now let's see whether they are actually useful for what we want to do. I need to go back to the objections the objectives of this talk. We want to assess whether this data is useful or not. And there are certain challenges. When we are talking about the complex machines, like the supercomputers, for example, then there are certain challenges. The model needs to be fast trainable. Otherwise, the prediction of today doesn't help for tomorrow. So if we act too late, if the model takes too much time to predict, then the prediction would be already out of use. Second, the data that we are going to train need to be small because the machine changes its behavior and the model should adapt. Therefore, we need retraining and retraining and retraining. Therefore, the model needs to be very simple, use little amount of data, and still produce, to some extent, acceptable results. Having all that said, let's see what we had in hand. We had to take something very simple. So we took an LSTM model, and this is a proof of concept. So we want to see if it works or not. If it works on the LSTM, then it works for everything else. Why LSTM? Because it's super good with sequential data, with timestamp data. It perfectly matches our need here. Then we need data. For data, we took the system logs from Taurus. This is a supercomputer sitting in Technical University of Dresden, has about 2,000 nodes, and is quite talkative. So it produces lots of system logs, and we can use that. Of course, there are also some parameters required, some hyperparameters. With trial and error, we realized that this table of parameters are something that will bring us to the final goal that we have. And of course, different values for each of these parameters has been checked. Some of them are shown here, and of course, for the sake of time, I had to shorten everything. But we can go into few of them. For example, the time bucket, which is shown on the laser pointer. So for example, the time bucket which is shown here, we took different time buckets. What does it mean? It means that I simply aggregate the log messages which are coming in 5 minutes, in 10 minutes, and in 30 minutes into one pack. This is a way to simply normalize the data further. Or for the number of epochs, we could go as small as 20 up to like 10,000. And we will see what would be the results if we switch between these wide range of data. And at the end, the system logs would look like this blue table here. Based on those categorization, We took the top 5, top 10, top 20 messages, and then we count the frequency of them appearing in every 10 minutes. In this particular case, there are 10 minutes. And in addition to that, there's also an accumulated sum, which means that all the system logs which are appearing in one single hour are accumulated together. As you see the example here, from 11 we have 0 messages coming here, and then at 11:20 there are 7 messages. And if you look at the column in the middle, you see that they are getting accumulated on top of each other. Okay, so there are technical details. We don't need to really take care about that, and we can discuss that afterwards. Now let's have some discussions about the data itself. So here, if the data behaves similar to the raw data, then we are on the point. We see that these anonymized data are still useful. Let's start with the most simple one, the learning rate. Now you see 2 graphs. They are awful, I know, but we need that for the discussions. On the plot on the left, you see that the learning rate is 0.1. It's amazingly big learning rate, as we know in the machine learning. And of course, the model doesn't learn anything, it just jumps over. And as soon as we reduce the learning rate to 0.001, then the model starts to learn. And that is the very identical behavior that we saw with the original data. So the anonymized data and the original data were behaving completely similar in case of the learning rate. Just another example. In this case, we touched the number of epochs. On the left side, you see only 100 epochs, I believe, right? Yeah, 100 epochs. And on the right side, it goes to 2,000. And then, of course, we stop that because of so much overfitting that happens there. As you see, the orange line is completely taking another pass and compared to the blue one, so it's not good anymore. And of course, we can automate that. We can stop training at a certain point. But again, the same behavior were observed when we were doing the same type of training on the raw data, on the original data, without the encryption. They were identical. So again, this test was kind of passed, and we realized that about 100 epochs is already enough, going back to our objectives. So the model trained fast. Already at 100 epochs, we have a very satisfying loss values. And the last example that I want to show here is the number of steps. Number of steps means how many steps in the past should I look into to predict the next one, the next step. So should I only take 2 steps in the past to predict the next one, or should I take 6 steps in the past and look at longer history of the data to predict the next steps? If you look at the plot on the left, it takes only 2 steps, and we see that the prediction is not really prediction, it's just mimicking what has happened in the previous step. So the red dotted line is coming with a delay after the blue line. So it beautifully resembles the real data. But this is not what we want. We want to be on the point, so to predict what's happening. With the 6 steps, we already get there. So with 6 steps in the past, and 6 steps means 6 times 10 minutes, so it's only 60 minutes of data. With 1 hour of data, it is already good enough for doing a rough estimation and prediction of the system's the behavior. Okay, then I will stop at this point with the examples and go directly to the final numbers that we got. We have decided to take the cumulative sum because it was useful in this case. This is the result of lots of trial and errors. I've just give you now the results here directly. Then we realized that the 10-minute time bucket is better than having 30 or less 5. And for the learning rate, the 0.001 were absolutely enough for our purpose. More than that, well, less than that. Simply increased the length of the training and didn't brought any significant usefulness. The number of steps, 6 steps in the past means 1 hour, 6 times 10 minutes, was already quite enough for our purpose. And we must do the normalization, otherwise the network could not learn anything. So that was what we did manually. How about an automatic way? We implemented that using Keras, and then the Keras tuner was also used to further investigate into these parameters. And not that surprisingly, the cross-tuner confirmed the numbers and values that we got manually. So it was a second confirmation that our investigation was in the right direction. Now, how I can conclude this? So based on what we observed, we can say that with a very little amount of data, very simple model, we could get some sense, some predictions of the system's behavior, even with fully anonymized data. So I can say that this fully anonymized data is useful. It is not lost all the information which are relevant in this data set. However, there is of course a trade-off. So if you want more accuracy, then you need to train the model further. So not 100 epochs, much more. Not 60 minutes of data, much more. But still, with this little data, it works. As a proof of concept, it works fine. And for the future directions, we need to bind this data with other data, other sensor data. For example, the power consumption, the temperature information. This is not there yet. But then the final approach would be combining these two together to have a better understanding of the system and, of course, answering these questions, whether this model is actually good for what we are doing or not. With more data, we can probably answer that. And also where to define the threshold. We see that now the predictions beautifully follows the real data, but we need to draw a threshold. And if the prediction goes above or below that threshold, we should say that, okay, now the model is predicting something weird, so the system is abnormal, and we need to do something, take some actions. Switching off the machine, making a backup, do a migration, depends on the system that we are dealing with. That's all from my side. Thank you very much.
So, thank you very much. Are there any questions from the audience? Michael?
Thank you very much for this interesting talk. In case I would like to reuse your approach, your software, where is it published? Is it open source? Under which license it is published? Something like that would be very interesting.
It is open source. It is already published. We didn't choose a license yet, so it is already available on GitLab. We can share the information. Because of the exact license challenge, let's say, because we didn't decide, I didn't put that on the slide yet. But it is available and it will be available.
Further questions?
Sure.
Thank you for the talk. I have a question about understanding of the why you're doing this. Perhaps if you're now able to detect anomalies and some behaviors you want to detect, what do you then afterwards? Because you anonymized the logs and also serialized them. What do you do afterwards would be very interesting.
Yeah, thank you. That's a very good question. So the main motivation here comes from our environment there. So I'm using the data from Taurus. I'm not allowed to keep this data for more than 2 weeks. Therefore, for keeping them and preserving them, I had to find a way to completely fully anonymize them in a way that I can keep them for future. Since this hash key at the end are very identical, so it preserves the similarity between the system logs, even after 2 weeks, if I lose the original data, as long as I kept these hash keys, I could get a good feeling about which part is going wrong, whether it's a user login causes this problem, or it's a software update causes this problem or not. Of course, I cannot dig into that problem further than this, but I would understand which part of the system is causing that problem. And I hope that with a larger amount of data, we could have, again, a better understanding. So I'm now talking about a few hours, like 1 hour, 2 hours. But if it's like 2 weeks of data, 3 weeks of data, 1 month of data, then probably it would be better, easier to investigate, to go back to the history of the data, to plot this data and see what's happening there. So that would be the main motivation, and also hopefully the answer to your question.
Let me come with another question just in connection with that. You were talking about this idea of using other monitoring data, for instance, the power consumption or temperature rate. For the first idea, would have the advantage of not getting you into trouble with this data protection issues. And what are your ideas and expectations here? Can you say a little bit more on that?
Sure, yeah, that's also a very good question. Majority of the works in this field are considering this type of data, like the power consumption, temperature data, job submission, workload, CPUs, and so on. The main challenge here is that they do not deliver information. We see that temperature is going up and down, or we see that the power consumption goes up and down, but as long as we are not coupling them together, we cannot really investigate into the system and see what's happening down there. So the final idea here is to bring the system logs also into the scene. The others are already out there. So the power consumption is there, the temperature is there, but the system logs is somehow the missing part. All the works on the system logs are done on the plain data. And with these GDPR regulations, at the moment, it's extremely hard to keep this data. For large supercomputers, majority of them would like to somehow outsource this information to another company or another part of the system to get analyzed and so on. And this would be difficult with raw data, with original data. So the idea that, again, the motivation would be to couple them back again. So now we are focusing on the system logs, but it won't be a single island. It will go back to the power and temperature data.
Thank you. Anybody else who wants to ask a question? So if not, then let's say thank you again for this interesting talk. So in our next talk, considerations on the legal frame in which we are supposed to place our systems inside certainly will be topic 2. The talk will be given by Tobias Gebel and Selina Mudrak. Tobias comes from the Institute of Economic Research, the DIW in Berlin. It's one of the most important institutes in Germany for economic research. They are analyzing social and economic aspects of topic issues, and they are trying to place policy advice on this. On the other hand, the DIW is known as a provider of data and infrastructure for researchers all over the world. Selina is representing the Selbstregulierung Informationswirtschaft, SRIW. It's a non-profit organization that's trying to or thriving for a legal frame that is fostering innovation in the digital economy. They are for that in dialogue with policymakers and other authorities in order to get a legal framework. And they're also part of the European Steering Committee for Community of Practice for Better Self and Co-Regulation. In their shared talk now, they will give a very wide and interdisciplinary perspective and provide us with preliminary results on their work on the notion of crisis and the implications it will have on building systems for crisis management.
Ja, vielen Dank. Ja, im Prinzip möchten wir Ihnen heute den Krisenbegriff ein bisschen näher bringen. Einmal aus einer ökonomisch-unternehmerischen Perspektive und einmal aus einer juristischen Perspektive. Ja, unser Vorschlag hat allerdings keinen Anspruch auf Vollständigkeit, sondern wir fanden die Definition einfach für unser Vorhaben in Kolpo als passend. Auch noch ein kurzer Disclaimer vorneweg. Wir sind beides keine Techniker, sondern reine Anwender. Selina ist Diplomjuristin und ich selbst bin Soziologe mit der Fachrichtung auf Arbeitsindustriesoziologie, Organisationssoziologie und Wirtschaftssoziologie, um erstmal so den Rahmen kurz abzustecken. Ja, wenn man sich wie wir mit vielen anderen Kollegen in Kolpo mit Resilienz und Krisenprävention und Krisenmanagement befasst, dann ist es erstmal grundlegend, dass man im Verbund ein gemeinsames Verständnis zur Krise hat. Und wie man auf den ersten Blick sieht, kann der Krisenbegriff sehr weit gehen und sehr umfangreich werden, weshalb wir uns jetzt erstmal auf die ökonomisch-unternehmerische Perspektive konzentrieren und auf die juristische Perspektive. Wenn man jetzt die Literatur studiert zum Krisenbegriff, so findet man recht umfangreiche Definitionen. Wenn man jetzt aber mal alle Definitionen miteinander vergleicht, so sind wir auf folgende Definition gekommen. Unternehmenskrisen sind ungeplante und ungewollte Prozesse von begrenzter Dauer und Beeinflussbarkeit sowie von ambivalenten Ausgang. Sie sind in der Lage, den Fortbestand der gesamten Unternehmung substanziell und nachhaltig zu gefährden oder sogar unmöglich zu machen. Und dies geschieht durch die Beeinträchtigung der Unternehmensziele, deren Gefährdung oder gar Nichterreichung, was gleichbedeutend ist mit einer nachhaltigen Existenzgefährdung oder Existenzvernichtung der Unternehmung als selbstständige und aktive am Wirtschaftsprozess teilnehmende Einheiten. Wenn man diese Definition jetzt mal kurz auseinander nimmt, so haben wir im Endeffekt 5 Kernelemente. Das ist einmal, eine Krise ist kein statischer Zustand, sondern ist ein Prozess, dem eine Entwicklung vorausgeht. Sie ist nachhaltig, das heißt, auch wenn die Krise überwunden ist, wirken die Folgen noch nach oder die Ergebnisse oder was man daraus gelernt hat. Sie ist ungeplant und ungewollt. Sie kann die Unternehmensziele gefährden oder sie gefährdet die Unternehmensziele. Sie ist nur begrenzt steuerbar und ambivalent im Ausgang. Das heißt, es kann gut gehen und es kann schlecht gehen. Krisen treten allerdings selten spontan auf, sondern sind immer ein Entwicklungsprozess. Und im Prinzip lassen sich 4 Phasen dabei unterteilen, wobei ich vorwegnehmen muss, dass nicht jede Phase eintreten muss, was sogar gut wäre. Die erste Phase ist sozusagen die potenzielle Unternehmenskrise. Das ist im Prinzip der Normalzustand einer jeden Unternehmung. Hier sind Krisen grundsätzlich möglich, aber nicht vorhanden oder wenig wahrscheinlich. Das ist allerdings die zentrale Phase, wo das Unternehmen sozusagen sein Rüstzeug schafft, die Vorausplanung hat, um Krisen bewältigen zu können und wo Alternativplanungen sozusagen vorausgedacht werden für potenzielle Krisen, um im Endeffekt die Reaktionsmöglichkeit im Eintrittsfall oder im Gefahrenfall zu erhöhen. Die zweite Phase ist die latente Unternehmenskrise. Hier sind Krisen verdeckt vorhanden und die Wahrscheinlichkeit eines Ausbruchs ist recht hoch. Bei der Wahrnehmung dieser Krisenmerkmale können allerdings noch geeignete Maßnahmen ergriffen werden, um die Krise abzuwehren, sodass es erst gar nicht zum Ausbruch kommt. Die dritte Phase ist dann sozusagen die akute, aber noch beherrschbare Krise. Hier sind die Wirkungen und die Folgen der Krise für die Unternehmer bereits deutlich spürbar und es besteht ein hoher Zeit- und Handlungsdruck, um sozusagen diesen entgegenzuwirken. Handlungsmöglichkeiten sind vorhanden, allerdings nur beschränkt, aber mit Mobilisierung sozusagen aller Kräfte im Unternehmen ist die Krise bewältigbar. Ja, die vierte und abschließende Phase ist dann sozusagen die akute und nicht mehr beherrschbare Unternehmenskrise. Hier übersteigen die Anforderungen an die Krisenbewältigung die Handlungsmöglichkeiten und die Spielräume der Unternehmung. Der Handlungs- und Zeitdruck steigt weiter und die Existenzgefährdung ist im Prinzip nicht mehr abwendbar. Das heißt, mit zunehmendem Verlauf nimmt der Handlungsspielraum ab, also die Möglichkeiten, wo ich noch was unternehmen kann. Gleichzeitig nimmt aber der Zeitdruck zu und die Möglichkeiten und der Handlungsspielraum sozusagen ab. Also sozusagen mit dem Zeitverlauf in erhöhter Zeit und Handlungsdruck bei rückgehenden Handlungsmöglichkeiten. Ja, wenn man jetzt den Blick auf die Ursachen von Unternehmenskrisen wendet, so kommt es häufig zu einer Vermischung oder Gleichstellung von den Ursachen für Unternehmenskrisen und den Symptomen von Unternehmenskrisen. Hier ist jedoch zu differenzieren und Symptome sind im Prinzip die sichtbaren Folgen einer Krise, sind aber nicht sozusagen ursächlich für die Krise. Sie wirken sozusagen als Indikatoren, dass eine Krise vorherrscht. Beispiele relativ banal dafür sind ein Umsatzrückgang, Produktionsrückgänge, Abbau von Mitarbeitern oder auch Zahlungsschwierigkeiten. Ursachen sind hingegen die tatsächlichen Gründe für eine Krise, und die können sowohl im Unternehmen selbst liegen, also interne Gründe sein, Ursachen sein, oder können von außen auf das Unternehmen einwirken, also externe Ursachen sein. Die internen Ursachen ergeben sich dabei aus dem Handeln des Unternehmens selbst. Sie stehen quasi in einem direkten Zusammenhang mit der Unternehmensleistung. Beispiele hierfür wären Fehler in der Unternehmensführung, also in der Planung, Steuerung oder in der Kontrolle, Liquiditätsprobleme, eine gewisse Krisenanfälligkeit durch die Produkte oder Dienstleistungen, die ich anbiete, oder Anfälligkeiten aufgrund der Unternehmensentwicklung. Das heißt, ich bin zu schnell gewachsen oder ich bin zu langsam gewachsen. Das können aber auch Strukturprobleme sein oder auch eine gewisse Trägheit im Finden von Entscheidungen. Das heißt, ich bin immobil oder zu unflexibel in der Findung meiner Entscheidungen. Ja, externe Ursachen hingegen wirken von außen auf das Unternehmen ein und haben keinen direkten Bezug auf die Unternehmensleistung. Und typische Beispiele hierfür sind strukturelle und gesetzliche oder konjunkturelle Veränderungen im Umfeld. Das können globale Konflikte sein, wie ganz aktuell, oder pandemische Lagen, auch wie wir sie alle kennen, oder auch Umweltkatastrophen, die sozusagen von außen auf das Unternehmen einwirken, auf das ich keinen Einfluss habe. Ja, bei der Differenzierung ist jetzt allerdings zu beachten, dass die Krisensymptome des einen Unternehmens die Ursachen für das andere Unternehmens sein können. Wir haben es für uns definiert als Symptom-Ursache-Ketten, und hierfür möchte ich kurz 2 Beispiele geben. Ja, Unternehmen A hat einen fehlenden Zugang an Erzrohstoffen und kann dadurch sozusagen, das ist die Ursache, und die Folge ist, es kann bestimmte Maschinenkomponenten nicht mehr herstellen. Das ist das Symptom. Das Symptom, quasi die fehlende Herstellung von den Maschinenkomponenten, ist allerdings die Ursache bei Unternehmen B, weil sozusagen Produktionsausfälle beim Zulieferer sind als Ursache, und das Symptom ist dann der Personalabbau, da ich einen Minderbedarf habe. Ein zweites Beispiel ist eine ausbleibende Nachfrage bei Unternehmen A als Ursache. Das Symptom ist, dass quasi Zahlungen nicht mehr geleistet werden können. Und diese Zahlungsausfälle beim Abnehmer sind die Ursache mit dem Symptom, dass das Unternehmen B die Produktion drosseln muss. Grundlegend ist auch festzuhalten, dass Unternehmenskrisen in der Regel multikausal sind. Das heißt, beispielsweise, dass externe Ursachen erst interne Ursachen wirklich zum Vorschein bringen oder diese verstärken. Krisen entstehen auch nicht aus der Ursache selbst, sondern weil die Unternehmung jetzt sozusagen keine Antwort auf darauf hat, beziehungsweise nicht schnell genug reagieren kann. Auch das möchte ich an einem kurzen Beispiel illustrieren. Als Beispiel habe ich jetzt einen Hersteller von Kugellagern für Großanlagen genommen. Das Unternehmen wurde 25 Eigentümer geführt gegründet und hatte bis Mitte der 80er Jahre ein stabiles Wachstum. Mitte der 80er Jahre hat sich der Unternehmer zurückgezogen und es wurde Fremdmanagement. Das Fremdmanagement, ich verkürze jetzt mal, hat Fehlentscheidungen getroffen und Entwicklungen ausgelassen. Die Marktfähigkeit ging zurück, Schlüsselkunden gingen zurück, der Umsatz ging zurück, und sozusagen externer Input war die Wirtschaftskrise 2008, was zu einer Liquiditätskrise geführt hat, weil es sozusagen die weiteren Rückgänge an Kunden nicht mehr kompensieren konnte. Genau. Also grundlegend, wann ist eine Krise, wo fängt eine Krise an, und ist eine Krise für jeden eine Krise, ist immer eine Perspektivfrage, die das Unternehmen und die Branche sozusagen für sich selbst entscheiden muss.
Okay. Ja, in der restlich verbleibenden Zeit würde ich gerne noch einen kurzen Überblick darüber geben, wie die Krise aus einer juristischen Perspektive betrachtet werden kann. Erstmal mag man sich vielleicht die Frage stellen, inwiefern das beides zusammenhängt und warum eine juristische Perspektive in der Krisenbewertung durchaus hilfreich sein kann. Grundsätzlich kennt und behandelt auch das Recht Krisen und schreibt verschiedene Szenarien vor, die eintreten müssen, um von einer Krise sprechen zu können. und gibt anschließend Möglichkeiten, darauf zu reagieren. Deswegen habe ich 3 verschiedene Beispiele mitgebracht, die ich einmal durchgehen möchte. Grundsätzlich erstmal, das Gesetz selber spricht im seltensten Fall von Krisen selbst, sondern es gibt oft Synonyme, die genutzt werden. Wir haben hier einmal eine Übersicht mitgebracht. Die dunklen großen Kreise sind die Synonymwörter, die benutzt werden, und in den kleinen helleren würde man die Rechtsgebiete finden, aus denen sich praktisch in den Krisensituationen unter anderen Namen behandelt werden. Genau. Ich gehe zunächst einmal aus Beispiele überwiegend aus dem öffentlichen Recht ein, habe dort aus 3 verschiedenen Gesetzgebungsebenen Beispiele mitgebracht, einmal aus dem europäischen Recht, aus dem nationalen Recht und aus dem Landesrecht. Öffentliches Recht vielleicht eher im Sinne von, wann bahnen sich größere Krisen an, die jetzt nicht unternehmensintern sind, sondern viel mehr Einfluss auf ein Unternehmen nehmen könnten, und welche Voraussetzungen müssen dafür vorliegen. Aus dem europäischen Recht wäre es vor allem die Verordnung aus 2017, die wahrscheinlich, wer die Nachrichten ein bisschen verfolgt, in letzter Zeit öfter schon mal begegnet ist. Das ist die Verordnung über Maßnahmen zur Gewährleistung der sicheren Gasverordnung, aus der auch der Notfallplan Gas stammt, der ja zurzeit viel besprochen ist, insgesamt in 3 verschiedene Stufen eingeteilt ist: die Frühwarnstufe, die Alarmstufe und die Notfallstufe. Hier ist es grundsätzlich so, dass das Gesetz Kriterien vorschreibt oder Situationen vorschreibt, die vorliegen müssen, damit diese verschiedenen Stufen eingeleitet werden können. Im ersten Fall, in der Frühwarnstufe, wäre es zum Beispiel, dass sich abzeichnet, dass es eventuell zu einer zu verringerten Lieferung kommen könnte. In der Alarmstufe, die jetzt gerade ausgerufen wurde, dass tatsächlich weniger Lieferungen eintreffen, in der Notfallstufe schlussendlich, dass Gas tatsächlich knapp ist. Wenn ich jetzt zum Beispiel in der Industrie tätig bin und auf die Zulieferung von Gas angewiesen bin, so könnte ich bereits, wenn die Diskussion über eine Frühwarnstufe losgetreten wird, für mich ein Merkmal haben, an der ich erkennen könnte, dass es eventuell für mich als Unternehmen notwendig ist, zu gucken, wie ich vielleicht den Rohstoff Gas substituieren könnte, ob ich meine Produktion umstellen könnte. Und da würde das Recht praktisch mit seinen Vorschriften einen Rahmen dafür geben, welche Kriterien ich besonders beachten müsste. Um es kurz ein bisschen abzukürzen, gibt es noch 2 Fälle aus dem nationalen Recht. Das wäre einmal in unserer Verfassung der äußere und innere Notstand. Der äußere Notstand, sobald das Bundesgebiet der Bundesrepublik Deutschland mit Waffengewalt angegriffen werden würde. Das sind jetzt alles auch Krisensituationen, die etwas weitreichender sind, oder aus dem Landesrecht das Gesetz zur konsequenten und solidarischen Bewältigung der Covid-19-Pandemie in Nordrhein-Westfalen. Dort war es so, dass das Gesetz grundsätzlich als Kriterium vorgesehen hat, dass die epidemische Notlage von nationaler Tragweite vom Bundestag oder vom Landtag hätte beschlossen werden müssen und dass dann als Konsequenz der Eingriff in den Markt hätte stattfinden können, nämlich dass Rohstoffe zum Beispiel bestimmter Kategorien nicht mehr dem freien Markt zur Verfügung gestellt werden, sondern dass festgelegt werden kann, wer beliefert werden muss und sogar zu welchen Preisen. Ich mache jetzt mal weiter aus Zeitgründen. Wir haben für Unternehmen natürlich auch noch die juristische Perspektive und da vor allem das Insolvenzrecht. Das war für uns jetzt das greifbarste Beispiel und wir haben einmal versucht, es auf das Krisenverlaufsmodell, was vorhin bei Tobias schon zu sehen war, anzuwenden. Das heißt, auch hier sieht das Recht in den jeweiligen Stufen, zum Beispiel, wenn jetzt eine potenzielle Krise bestehen könnte, könnte man sagen, im Insolvenzrecht gibt es grundsätzlich die Pflicht, immer zu überwachen, ob mein eigenes Unternehmen eventuell in eine Krise kommen würde. Das heißt, aus dem Aktiengesetz oder dem Restrukturierungsgesetz leiten sich dort Pflichten ab. In der latenten oder in einer bereits akuten Krise können finanzwirtschaftliche Maßnahmen getroffen werden, gesellschaftsrechtliche Maßnahmen oder insolvenzrechtliche Maßnahmen, um diese noch abzuwenden. Und schlussendlich sieht auch das Gesetz die Krise dann erreicht, wenn die Insolvenzreife eines Unternehmens eintritt. Genau. Alles in allem lässt sich also feststellen, wie Tobias schon gesagt hat, dass die Krise kein festgesteckter Begriff ist, sondern wandelbar ist, meistens nicht aufgrund einzelner Ereignisse eintritt und das Recht eventuell hilfreich dabei sein kann, Kriterien festzulegen, die ausmachen, wann eine Krise droht und so ein bisschen in dem, mit dem wir uns beschäftigen, zu helfen, nämlich der Früherkennung von Krisen. Ja, falls noch Fragen sind, stehen wir dazu zur Verfügung.
Fragen aus dem Publikum?
Aus reinen Eigennutz, weil ich den nächsten Vortrag habe, zum Hochwasser im Ahrtal. Das passt ja schon irgendwo in die Definition einer Krise. Ich glaube, irgendwo in diesen Bullets habe ich das gefunden. Wie passt denn so ein Hochwasser in das ganze Konstrukt.
Ist das jetzt eine Frage an die juristische Perspektive, oder?
Je nachdem, wer von euch beiden das beantworten möchte.
Ja, grundsätzlich würde ich sagen, ist ein Hochwasser auch eine Krise. Ich habe das hier jetzt nicht auf den Folien aufgenommen, aber grundsätzlich, was ich jetzt aus meiner Perspektive sagen kann, gibt es da auch Katastrophenschutzgesetze, die vorsehen würden, dass die höchste Eskalationsstufe in den landesrechtlichen, also das ist meistens Landesrecht, der Katastrophenschutz, dass solche Fälle ja grundsätzlich präventiv verhindert werden sollen, beziehungsweise wenn es dann eintritt, gibt es dort bestimmte Handlungsanforderungen, welche Handlungen vorgenommen werden sollen. Also es ist schon eine Krise, sage ich mal, mit der sich das Recht beschäftigt. Also auch ein Ereignis, das unerwünscht ist, wo dann festgelegt sein muss, wie wird darauf reagiert und was muss vielleicht vorher gemacht werden, damit solche Krisen gar nicht erst eintreten.
Ich glaube, der Ministerpräsident hatte da nicht sofort so reagiert, wie es wahrscheinlich rechtlich vorgegeben war. Was hat er dann?
Den genauen Vorgang kann ich jetzt nicht bewerten.
Okay.
Ja, ich weiß, das maße ich mir jetzt nicht an zu sagen, dafür bin ich nicht tief genug in der Materie.
Andere Fragen?
Ja, vielen Dank, danke für den Vortrag. Ich habe eine konzeptuelle Frage, und zwar haben Sie von Symptom-Ursache-Ketten geredet. Also was man so kennt, sind Ursache-Wirkungsketten oder Gründe-Folgen-Debatten. Ursache-Symptom kenne ich eher so aus der Medizin, wo man erst ein Symptom hat und nach der Ursache sucht. Also müsste es nicht Ursache-Symptom-Kette heißen. Und konzeptuell war das dann in der Ausführung schon so, dass erst die Ursache und dann das Symptom quasi freigelegt wurde, und müsste man ja also eher die Ursache in den Fokus nehmen und nicht das Symptom.
Also prinzipiell ja. Ist erst die Ursache, die dann das Symptom hervorbringt. Bei uns ist es ja, also in Kolpo ist es ja so, dass wir sozusagen prüfen wollen, ist vielleicht jetzt eine ausweichende Antwort, dass wir prüfen wollen, sozusagen, wir wollen sozusagen Indikatoren suchen, bevor die Ursache überhaupt zum Greifen kommt. Und dafür sind die Symptome von meinem anderen Unternehmen sozusagen mit ein Prüfkriterium. Also wenn ich sozusagen einen Handelspartner habe oder einen Zulieferer und der kriegt Probleme, das ist ja dann schon eine Krise, was für mich dann ein Symptom ist, um zu sagen, Gegenmaßnahmen einzugreifen, dass sozusagen die Krise nicht auf mich überspringt. Aber eigentlich sind es Ursachen-Symptomketten, ja.
Anybody else? Okay. Considering the time, I would say thank you. For the next talk, I'm switch to English again and welcome Alexander Willner from the CIS GmbH. CIS is a technology company that's procuring geo-data for businesses and for the public sector. They are offering their own tool set and providing geo-linked data via several web platforms already. With the Leipzig semantic data community, they are connected via a whole bunch of successful open data projects, for instance, in the context of mobility data. And we know that CIS is a very good partner that is always ready to catch up new ideas and push them forwards and meet each challenge, even if is the internal competition we have between Leipzig and Sinzig in terms of global influence. So we will see whether you can meet this challenge today.
Thank you.
Your talk on two geo-linked data projects.
Thank you very much. And talking about challenges, I think one challenge is certainly time. So I have 15 minutes for 2 talks now. Let's see, I will try to keep up a little bit. Nevertheless, we're talking here today, or in the first talk, actually there are 2, about a serious topic that fits quite well in the talk that we have just listened to, which is extreme weather conditions. And actually how to deal with them, what to do about them, or let's say at least how to mitigate their impact. So very shortly about us, because this is important for this talk actually. Starting with the phrase, the greatest sight there is the world, go see it. And having this in mind, this phrase, 40 years ago, our company was established, 1982. Well, I was born back then, but certainly not old enough to establish it my own. The headquarters is in a small town called Leipzig, in the western part of Germany. This is basically the most important part of this slide for this talk. And then you see a small other fox in the main capital in Berlin. This is the next future headquarter. Now let's see, at least this is one part that I'm personally establishing right now. And credit where credit is due. Most of the work has been done by Richard and Christopher. Richard is actually on the list of speakers. Christopher is on his parental leave, and I have the honor to talk a bit about what we have actually done. So let's talk about the flood of the century on the 14th of July last year. When we look at the analysis of the precipitation, we see on the 14th of July last year, it started to rain, actually a lot. Then it got worse on the 13th, and then it got very extreme on the 14th of July. So there was already a lot of rain. The ground was rather wet already. The wind pushed the clouds into the western part. That's actually where Leipzig is. And to summarize what we have just seen on the slide is that on a single day, on the 14th of July, it rained more than the average sum of the last years. So this was immense. And I don't want to talk just about numbers, but more about the impression. So what happened? What was it like there? I probably have seen a lot of pictures and videos on TV. I was there a little bit later because it was quite difficult to enter the area back then, but actually really looked way worse than on this picture. And of course, a lot of infrastructure was destroyed. It was not even possible to cross the river. You had no internet, no leased line internet for at least a month or two. Well, the Deutsche Telekom offered a flat rate for everyone in this area. Oh, actually, I think it was Germany-wide. Nevertheless, a lot of infrastructure was destroyed. So streets, bridges, as I said, telecommunication, power grids. You have seen pipes from gas grids all over. Actually, can imagine there were cemeteries that were washed out by the water. So it was massive. And the question then is, or one of the questions was, where to find information. Where to find information about medical care, child care, information points. So what to do next? You need data, you need information, is one of the most important things. I think, well, here in this room, most of you are, or your heart is beating for data and information anyways. So the question is, how was information distributed back then? So we talk about the Citizen Information Portal. So in this Citizen Information Portal, you get information from different distributed data sources. Well, the affected citizen is probably not smiling as much as you can see here on the slide. Anyways, this was the picture my colleague used. So there was an official data portal by the Supervisory and Service Directorate. It was managed by one single person. This one single person received an email. Well, depending on the infrastructure, may or may have not received an email. There was rather long update cycles. This person had to update the geoinformation system. Barely usable on mobile phones. and as you can imagine, you most probably, if you don't have a house, you might have at least your mobile phone with you, and then you still can't access this portal. No offline usage at all, and as licensed. But the most important part is it was offered around 2 to 3 weeks after the event. There was nothing like this. And this was the situation. And then now I would like to talk a little bit about how information could have been distributed, how maybe it should be distributed in the future. I think there's much room for improvement. As we were impacted ourselves, we had some intrinsic motivation to help in this area. So there are a couple of requirements. So first of all, we need to gather information from different distributed data sources, and the update have to be seen immediately, or at least as soon as possible. Non-technical experts should be able to update information, not only those that know how to use a GIS, a geoinformation system. Offline usage is certainly quite important, mobile usage, and of course we need some sort of API to interconnect the different data sources, to publish information, to feed this into other systems. So extreme situation requires some sort of extreme solutions. So what we need is something very simple. So something like Google Docs, something that everyone knows how to use. Use this as a data source and push it to a mobile-friendly offline version as soon as possible. What we need is different authorized accounts, not just a single person, but instead multiple persons that can update the data immediately, that they do not know a lot about geodata, that needs some sort of support on how to encode a city code, a street, to coordination points. So what you see here is actually the back end of a prototype that we have established rather quickly. This data portal that was provided by us and Yellow Maps. So basically this is a Google Docs sheet with some scripting behind it. Our friends from Yellow Maps supported us in designing the front end. A bunch of colleagues from the city of Leipzig were able to update just the table. Then we had an API to extract the JSON information, CVS, Excel, even downloading a PDF to print it. We were in contact with the police and the fire stations to provide even more information there. So there was a big demand for such a system, and there certainly will be demands in the future for these kind of portals in the future. And actually this was just a quick prototype. What went well? It was already online 7 days after the flood. Ideally we should have something like this before the next crisis. Google Sheets was quite nice, or was quite okay for non-technical people to update the information. I mean, you're all data experts here, but at the end it has to be usable. Google-based authentication, fine. Almost everyone has a Google account nowadays. The support for adjusting coordinates, and all was rather free. However, this is certainly not the way it should be. It was what we established in a few days. It has to be usable and quick. And it was used only in Leipzig. But I see there is a demand in Germany or in Europe, or actually worldwide, for these kind of information portals. Well, I'm open to talk about joint proposals, maybe, so we can work on a proper solution for Germany or within Europe. And of course, what we did was practical. I mean, at the end, I also worked my PhD thesis about linked data. I don't really like Google Sheets to provide data. It should be something a little bit more sophisticated. So we should extract information from other available linked data sources, export linked data. This is something that a future portal should probably do. Polygon information was not easy to add in such a table, and certainly, well, maybe a Google account is not the way to go. So this was just a few minutes as an overview what we did in the crisis context, and there is certainly a lot of demand in the future. I think there will be more crises, climate-based or not, and I think there's big demand for sharing crisis information. Thank you.
Short gap before getting the second presentation by Alexander.
Again from my side, yeah.
Anybody who wants to place a quick question?
What about the older people? How do you warn them?
How to warn them? Yeah, there were, how's it in English? Sirens? So, loudspeakers that didn't work. Then there are applications, again, not for old people, that didn't work. Then there was recently a test for sending these special messages on mobile phones. This also didn't really work out. I would say if you're old, you're screwed, maybe. But also, as I mentioned before, the information was available quite early. So some of our colleagues that know a little bit more about weather than me also told us, okay, look at the numbers. There is something coming. Please be prepared. And nothing like this was sent by the state. Well, way too late. Yeah, and some of our colleagues lost their houses, actually, 2 of them. It could have been avoided, I would say, if the information should have been pushed earlier, maybe some AI on the data that predict better what could happen. So I think there are technical solutions for this problem. Okay.
Anything else? So I'm sorry to have to push a little bit.
Yes.
To give you time for your presentation. Yeah.
Yeah, or 5. I will skip the introduction of the company, obviously. So let's talk a little bit about weather again. Now about a project that tries to make weather information more usable. Again, maybe for AI, maybe for these kind of crisis portals. So skipping about us, the important part again, Richard and Christopher did most of the work. I'm just here to talk about it. So, motivation. Why to talk about weather? Well, weather is topic number 1 for small talks. So, after this presentation, we certainly can talk a little bit about weather. So, this is certainly one of the most important reasons why to talk about weather. The second most important reason might be that around 80% of the worldwide economy is somehow dependent on weather information or the climate or climate change in general. And you all know that open data is basis for new business ideas, allow for economic growth, and so on and so forth. We need more open data, accessible data, even better annotated data. And the question is, where is all this data coming from for this economic growth? Where is this open data coming from? So when it comes to weather information, in Germany, this is the German Weather Service, DWD. And their task is to offer open geodata and allow usage for economic growth and other applications for third parties. And the goal of this project that I'm talking about is to make this information a little bit more usable. I will come back to this in a second. So offering APIs, meta information, transform coordinates and information, attach information with each other, link data with each other, and also provide some sort of feedback loop. So the current situation is like this. You go to opendata.dwd.de, and then you can see something like this, and the data is available, and you can download it. So task fulfilled. I think we're done here. It's anyways not quarter past 12, so we could go to lunch, and I don't want to stand between the lunch and a hungry mob of people. But maybe still I try to invest 5 more minutes to talk about what could we do better than what we see here. So the open weather data is available. That's fine. But it's not very handy to use. So there's almost no meta information, no real interface. Well, you can download data dumps, rather large data dumps, no pre-processing. This is a minimal what the German Weather Service could do. What's the approach of this project? Well, it's a typical ETL plus services approach. Downloading the gigabytes and terabytes of data, updating the data, and then pre-process them. So coordinate transformation at some point that I mentioned before, link other data to it, remove some information that is not of importance for our use cases, and at the end, well, do some quality assurance and store it to a centralized Postgres database, filter it by time, by coordinates, and so on and so forth, and then offer some use cases on top of it. Talking about the use cases, so here in this project we have 3 of them at least, I think 3. So one is event management, so automated messages to participants of an event to take your umbrella, something like this. Quite interesting is the energy industry. This is an area where we are quite active currently. It's about project planners that want to create a new wind park. They need more information about historical weather information, how to predict weather conditions in the future. Is it worth to invest money to build a new wind park? Things like this. And then, of course, e-mobility, optimize routing based on weather conditions. 2 examples. This is a fair portal. So you could think about something like Amazon or a combination of Amazon and Google Maps for weather information. So you specify what you need, transform the data. You can have some preview what kind of information you will get, and then well, in the context of this project, but as a dissemination or exploitation method, you will be able to pay for the services, because this is quite interesting, important information for project planners and others. Going to skip this information. Other part is integration of a GeoNetwork catalog, which you probably all know, to offer the, better or more metadata about the information that the DWD offers in a more semantic way. Yep. This is rather a quick overview of this. So weather information is difficult to assess. It is a lot of information. You have to be a rather expert, and I'm not an expert, in weather data. We make, or in this project, we try to make it more accessible. We have different use cases for them. Actually, we have 3 use cases on top of our services to see, okay, there is an added value of having weather information more accessible. And I think there's a lot of potential in the future, in particular when we think about climate change, renewable energies, to have more and more or better access to this kind of information, not only in Germany, but again, European-wide actually. So that's it. Thank you.
Thank you very much. Still an opportunity to ask questions. Everybody too hungry?
Probably.
Sorry.
Okay, thank you.
Okay. Before leaving you for the lunch break, I was asked to convey some information concerning a small switch in timetable for the afternoon session. So the coffee break will be on 2:30 instead of 3 p.m. So in case you wanted to attend a certain slot, you should take this into account. That's not shown in the original timetable like this. So now, have a lunch and enjoy your meal.
To introduce Eva Hörster from DATEV, who's going to tell us about deep supply chain monitoring.
Yes, I will be presenting today about a deep supply chain monitoring tool which we are developing at the moment as part of the COIPU project on crisis management and resilience. And even though it's me presenting today, all of this has been joint work with Implisense. Why is our focus on supply chains? Recently, there has been a lot of newspaper coverage about events that subsequently led to supply chain disruptions or shortages of different products. For instance, we have the Ever Given container ship blocking the Suez Canal and causing delays for the deliveries of many products. We have had a baby food producer in the US having to shut down its factory, which led to a severe baby formula shortage across the US. We have the semiconductor chip shortage and its implications for car manufacturers, such as Mercedes or others as well. And this is about some air conditioning coolant. We have had the war in Ukraine leading to rising energy prices, but also shortage in sunflower and less known corn oil. And we would expect another year of supply chain problems according to all the newspapers. These are all just a few examples, and over the last few years we have increasingly read about supply chain problems and gotten used to pictures showing containers in transit, should be on a ship, train, or on the road. From a company's point of view, or if not company, then a bigger organization, it's mostly missing transparency regarding its own deep supply chain that weakens its competitive position and therefore its resilience. In that case, we define a deep supply chain as not only their direct suppliers, the tier 1 suppliers, so we see the tiers relative to one's company, but also indirect suppliers, as would be tier N or tier 2 or tier N. To address the missing transparency problem, we propose an information and optimization tool that aims to answer the following 2 questions. Am I affected? So given an event has happened, is my company affected? And if so, how severely is the company affected? Here one would expect to get automatic notifications, a forecast of potential impacts and recommendations on how to mitigate effects if possible. The second question our tool is supposed to answer is, should I have been prepared better? Could I have avoided some of the implications that have been there? Would I have been better prepared? So for instance, this can be done by revealing structural dependencies along the supply chain, such as regional dependencies, and it could also be done by proposing alternative solutions, which for instance would diversify further. Who would be able to use such a tool? First of all, it would be businessmen, businesswomen, company owners, and so on. But also it could be consultants. It could be any kind of consultant. It could be business consultants, but also politicians. It could be public administrations. On this level, I suppose we wouldn't need that detailed information, but it would be a similar kind of information, just aggregated for regions or industries, for instance. What might such a tool look like? That's it. What would be a specific use case scenario? Let's suppose an event has happened anywhere in the world. In our example, it will be a hurricane in Houston, Texas. That means a natural disaster, but that is just one type of event we could consider. If the user's company is now forecast to be impacted either directly or indirectly, he or she would receive a push message onto their mobile phones showing a warning. He may then log in to receive further information about the impacts of the event. This entry point page is personalized to his company. You can see this. In our case, we've made up a synthetic company called Glue, which is in the chemical sector. And on the bottom right, you would be able to review information about which assumptions have gone into the model or impact calculations in general. He gets summarized information about the event that occurred, which causes the alert. Here he gets some notification about which products are impacted and why, for instance, infrastructure failures in this case, or what the root case of the problem is. On the right case, there's also already some recommendations given, very summarized. Now, to gain further insight, he clicks on the Details button, and the actual detailed risk monitoring page starts. This is how this would look like. We can see here, this here is the supplier that is affected directly. It's a direct supplier, that's the yellow cone. This is where the event happened, but there's also an airport which could be affected, and the port, which he probably will use in order to ship some of the products to the destination. This is Hamburg in Germany. That's just what we made up. Then also, when you click further, here you have on the right side, it's different summarizations. It says, first of all, we have problems with a certain product caused by this hurricane in Texas, but then also we might have problems. This is less certain, because we suppose that we have indirect dependency on the US. For these indirect dependencies, we can only approximate them, because we often don't know exactly where the supplier in the US would sit, and if we would really have a second, third, fourth tier supplier. This is why this line is a dashed line. But there could potentially be another problem, and this could then impact this direct supplier in Sweden, which supplies a different product to our company, for instance. If we click here, we can then also see why this direct supplier down here is affected. This is the name of the company, for instance, and this says, oh, it's the. It could be that either the transport by road is affected, or that there's some problems in the port itself due to floodings that have been caused by the hurricane. How would we now start if we wanted to implement such a vision of a tool? First of all, we need data. And there's different types of data that we will need, and that will need to be loaded in the graph. The first data is about the company itself. We would need data about where it is, what sector or sub-industry it acts in, what are its products, which products does it need in order to produce things, where is it, all these things. Then we would need to model the supply chain itself. So for tier 1 suppliers, we will suppose that we have the knowledge of where they are and who they are, and also which industry or product groups these suppliers will deliver. And then we will need to approximate all the other tiers that come further down in the supply chain. We can do that by using so-called MRIO tables. These are general tables which just tell you what the recipes are for one product group, which product groups in which regions are usually imported for this. And then on top of this, we will also need logistics and infrastructure data. And finally, on the other hand, we will need event data. We need to have a breadth of different classes of events. We need to know what happened, and if possible, we would want to know that quite quickly after it happened. That could be natural disaster, political crisis, it could be cyber attacks, and so on. So we would want to have a lot of events in there. We would need to know the strengths of the event, or who was impacted, what the impact was, and then we also want lots of different classes. And then we would need something to calculate the impact it would have. At the moment, we already have this nice page compiled by Niels, which shows how many entities we already have in the graph for this demonstrator, and there's about 17 million at the moment. You can see there's disaster data, there's sector data, some supply chains, different companies, countries, but also infrastructure data such as airports, ports, power plants, and so on. Where are we now? This is how it looks at the moment. It's not exactly what I've shown previously in these scribbles, but it looks quite close, and there's different things. We will show it off just outside this room in the coffee break, so please stop by and we can show it to you. You can have your comments and get further details. Thanks.
Thank you so much. Really exciting to see this prototype. Have we got any questions for Eva?
What is the basis for your modeling? Are this data from or that you have as Datev because you have many companies as your clients? Because all these things are more or less should be thought from within a company, and so the question is how to get or what is the modeling basis for really understanding what's happening in the world?
So that's a good question, and it's partly yes and no what you said. So some of the data we will use is internal data, and so internal to a company, or in our case there would be multiple companies which are our clients. And then other data is publicly available data, such as these I/O tables or the event data. For these internal data, there is different things you can assume. Either you have a platform and somebody is going to upload their supplier data or data about themselves, so that we could then calculate on basis of this, or for our direct clients, we could extract data about their suppliers, because we do know that, but we wouldn't make these publicly available.
Does SCORE play a role there, the supply chain operation model, or what the standardized model is?
Say that again?
SCORE, S-C-O-R.
I don't know what that is.
International standard for supply chains. Because I know that there are many interesting standards about business processes within, but I have not yet seen an international standard or so for supply chain descriptions.
I'm not aware of this, but that's a good point.
I can answer this question actually. So, because SCORE is part of our Teilvorhabensprojektbeschreibung, in terms of that we want to look into a way to create these parts of the knowledge graph as a SCORE model. We have a SCORE representation in RDF, but I know that Infineon has its own supply chain ontology, which is part of a broader production and for the manufacturing industry. So there are different approaches which we are using. That's the answer.
Any other questions?
Hello. First of all, very nice presentation. One question regarding the event data that you mentioned. Which would be the sources for that event data, and how do you verify if that event data is not fake news, for example?
So far, what we have in there at the moment, there's different sources. We have different structured sources where we know it's been edited and already put in tabular form, and we can load it and map it directly. But ultimately, what we would want is also to scrape news pages and Twitter. I think some people in the consortium are already looking at this, how to get event data from Twitter, for instance. But these fake event thing is, of course, a topic then. I don't think it's that much of a problem in editorial data.
Well, thank you.
All right, well, thanks a lot for your talk. we have Johan Lumke from IHK, who is going to tell us about, I forgot what? Pflanzenölproduktion.
Yeah. Welcome. It's my pleasure today to present to you the topic resilience in agri-food supply chains, exemplified for the sunflower oil production. And this is, we as IAK Agrar Consulting are a private company and associate in the Koipu project for the domain of agriculture. Yeah, so who are we? We are an independent agricultural consultancy, initially founded in 1981, and after a couple of transformations are now running under the name of IAK Agrar Consulting. And the business is divided in two sections. On the one hand, we have the management consulting for the domestic market in Germany, and also an international section for cooperation and consultancy for other countries. And our headquarters here in Leipzig, locally. And first of all, I have to announce a disclaimer that we, rather than computer science, used our agricultural production perspective as instrument for this work. And first I'll give you a motivation why to sensitize you for the topic of resilience in agriculture. And then I will characterize the value chain, first for the agricultural primary production, followed by the vegetable oil production. We'll look at uncertainties impacting the income statement of agricultural enterprises, and then at the end I'll give a summary. So yeah, here we see the profit per hectare of agricultural legal entities here in Saxony-Anhalt. And on the vertical axis, yeah, you see the profit in euro, and the green dotted line is the linear trend pointing downwards. And you see that the recent past has aggravated, and that negative incomes turned out for the agricultural legal entities, and this is very much likely to aggravate in the future. So what are the reasons why the companies couldn't make profit? As we have all experienced the extremely dry weather during the latest growing seasons, a weak price level for agricultural outputs, and unused potential for increasing production efficiency still to be released, and skyrocketing input prices, for example labor, soil, and very recently also the fertilizer. We will come to that later. And there is definitely a need to sensitize agricultural enterprises to this situation, and early indicators must be identified when particular risks could occur. Excuse me. This is a scheme for the value chain of the sunflower oil production, and we have the main value chain in the middle, which starts with the primary production in the agricultural enterprises, and then goes to the processing inside of an oil mill. And accompanying this, we see two parallel supply chains, which is on the one hand the service supply chain, and on the other hand the input supply chain. And driving factors for the primary production are obviously the weather, the soil, management and policy play also an important role. And all of this phrases you can see up there, those are all sources of uncertainty. And our system our approach was to take an income statement, a typical income statement of a crop-producing agricultural business. On the one hand, the primary production, and on the other hand, the oil mill. And here you can see the positions for the income sides, and we matched direct and indirect factors, which are sources of uncertainties, and which try to find the real reasons for the uncertainties. And also for our system, it was important to assess the intensity of impact and the variability on a scale of from low to medium to high. And in this presentation, I will focus on the agricultural primary production, and we will start with the market price, which is driven by the market mechanisms and also the amount traded, and the main driver is a globally estimated harvest, and also related to this the stock volume of already stored the already stored product. And we can observe here a decreasing sunflower stock, and the forecast is still uncertain what will happen. The current forecasts are probably not valid anymore because we have these following factors. For example, weather phenomena and geopolitical issues, like the two major producing countries, Ukraine and Russia, right now conflicting, which is affecting dramatically, and the energy prices. And we found different data sources to assess or to forecast these factors, the development of the factors. And for the weather phenomena, it is easy to do web scrolling for news about weather phenomena. And for the geopolitical issues, there's already a food export restriction tracker to see how this is developing. And energy prices, there are oil and gas future prices, which also state or tell us something about the future development of prices. And now I will focus on the yield, on the field's yield, which is obviously most dependent on environmental factors like weather, soil type, weather divided in precipitation and temperature. Finally, the most important variable is the soil moisture, so-called usable field capacity, the water available to the plant in the subsoil. And for the sunflower production, not too much precipitation is needed, but important is that it has to come in a very narrow time window, and otherwise, if it occurs to other times, this has opposite effects, and we have to have, for example, a long dryness between ripening and harvest for 150 days, so that is very beneficial. And to make forecasts, we have to measure the subsoil moisture conditions after winter time, to then make statements about future harvest. And for this, maps are available. And then, one has to observe weather forecasts and by that calculate and simulate the usable field capacities which result. Okay, and now we have the uncertainties on the expense side. We also divided it into two participants of the supply chain. And now I will focus on the fertilizer prices, which are causally dependent on energy prices. So there's a very high correlation. And we can observe here the steadily inclining trend of the fertilizer prices in general. And this is, as I said, for energy prices. The gas price is in the center of it. So we need to observe the oil gas price futures. Then whether there is demand backlog. So the past purchases patterns have to be assessed and used in the forecasts, whether there's still a high demand upcoming in the future. And the big question for the fertilizer industry is what China is doing, and it is important to observe news on the internet and scan them for relevant infos. So at the end, the summary, one can summarize that uncertainties are of global origin for the agricultural production. The volatility has increased, the price volatility, and weather-related risks severely endanger the yield, and it's only aggravating in the future. What I didn't tell is that grants and subsidies by the Common Agricultural Policy of the European Union as an unconditional income to farms is to be diminished and reduced. So farms need to rethink and reorganize their production and management, and it is therefore essential to build a good decision support system, which could be a dashboard. And crucial for the prevention and possible strategies to improve the resilience would be advance the knowledge of the possible risks, use of analysis tools, and to develop mitigative strategies.
Thanks a lot. Really fascinating to see all the factors that go into the productivity of the fields around us. Any questions to Johan?
Maybe not only the question to you, but I'm asking myself all the time, what is the difference between resilience management and risk management? Or is it, as in German, alter Wein in neuen Schläuchen?
Yeah, the resilience aspect very much or pronounces the also the not only the robustness to survive in a time of stress and shock, but also the adaptability and the transformability as as abilities to react or to even prevent and risks. Yeah, so that's a difference to the classical risk definition most of the times.
Thanks for the presentation. In which way did you formalize, or do you think you can formalize your analysis, and maybe also make this a similar analysis on other sectors or on other, because your example was very specific, and I think you put a lot of effort into it. And the question is actually, what would be the effort to do the same analysis for other sectors or for other crops or so on?
So the analysis tool which you mentioned could be to take one financial or financially relevant position of the to for example take the income statement and look at the total income, whether it will stay positive or negative, or you could look at the liquidity to see how if a company can stay functionable inside the supply chain. This is, I guess, the universal component which could link this project to others.
We could do one last question if there's any. All right, well, thanks again for your talk. So I think the next talks are online. So I'll ask for some support to get the presenters connected with the room. All right. Can you hear us all right? Or maybe say a few words so that we can check if we can hear you all right.
I'm Smita here. Can you hear me?
That's perfect. So, without further ado, let's have the third talk of the session by Smita Haradan from the Wichita State University.
Are you able to see my screen? Are you able to see my screen? Hello? Hello? Can you see my screen? Is it audible? Okay, then I'll proceed. I can see some people nodding, so I'll proceed now. My topic is on multispectral deep learning models for wildfire detection. I'm Smita Haridasan. I'll be presenting on behalf of my committee. My advisor is Dr. Ajita Rattani, and other members are Dr. Zalalam Demise and Dr. Atri Datta. We work for the Disaster Resilience Analysis Center at Wichita State University. Starting with the outline of the work, we'll proceed with a brief introduction, and then we'll go with a problem statement, data set, methodology, experimental protocol and results, conclusion and future work. Starting with the introduction, wildfires are large, destructive, unexpected fire, often caused by human activity or natural phenomena. 90% of wildfires are caused by human. For example, campfires left unattended, burning debris, downed power lines, negligently discarded
We can't see your
cigarettes.
screen at all. You're not sharing it anymore. Can you share it again?
Okay, I'll do it again. Are you able to see the screen? Okay, I think I'm sharing the screen now.
Yeah, that works.
Okay. So I'll start from the beginning. My topic is on multispectral deep learning models for wildfire detection. I'm Smita Haridasan. My advisor is Dr. Ajita Ratani. Other committee members are Zalalam Demise and Dr. Atri Datta. We work for the Disaster Resilience Analysis Center at Wichita State University, US. Starting with the outline of the work of the presentation, we'll go with a brief introduction, and then I'll introduce what the problem statement is, and then I'll give a brief introduction about the data set used for this experiment, the methodology, experimental protocols and results obtained, conclusion and future work. To start with the introduction, wildfires are large, destructive, unexpected fire, often caused by human activity or natural phenomena. 90% of wildfires are caused by human, for example, campfires left unattended, burning debris, downed power lines, negligently discarded cigarettes, and intentional act of arson. Thousands flee in the wake of wildfire. As per US Fire Administration, 56 fire fatalities had happened in 2022. This is a screenshot of the recent news of wildfire that happened in Europe. Wildfires forced Germany, Greece and Spain to evacuate residents. Spain, Germany battle wildfires amid unusual heat wave in Europe. This is a fire map obtained from NASA Earth Object Observatory. This shows the wildfires that has been happening starting from March 2001 till until recently. So you can see how many wildfires that has been happening and how much of land is getting affected, how many lives are getting affected. So it is a serious problem in most of the places all over the world. So the motivation of this work is early detection and instant reporting of such fire incidents are very important to mitigate the damage caused by wildfire. The existing systems are traditional fire detection systems involve sensor-based smoke detectors. Sensor-based smoke detectors installed indoors must be in proximity in order to detect fire or smoke, but they do not give location of fire or smoke. Apart from sensor-based systems, there are computer vision-based methods, machine learning methods, deep learning methods, which are existing in the recent literature to solve detection of wildfire in images. So the problem statement of our research is to propose multispectral deep learning model that combines information from 3 different spectrum for accurate fire detection. We've used the dataset from these 4 sources: FD dataset, FireSense, DeepQuest, and FergFire. This is a brief introduction about the dataset. FD dataset consists of fire incidents like fire on car, boat, forest. It also contains fire-like objects like burning clouds, sunset, glare, and red elements in no-fire images. This usually creates a confusion that appears like fire in the fire images. FireSense consists of videos with fire in outdoor and indoor settings like fireplace, kitchen, campfire, grassland, and forest fire. It also contains videos of night traffic, indoor decorations in the no fire category. DeepQuest contains images of fire accidents including vehicles, building, kitchen, and wildfire. FergFire contains videos of fire that include occlusion, clutter, different scales, camera calibration, vibration, motion blur, reflection, and a variety of bright and contrast conditions. So starting with the methodology, we have considered conducting 3 experiments, starting with the evaluation of individual models, individual deep learning models. Second experiment, we did a fusion of 2 spectrum, and the third experiment was fusion of 3 spectrum. So the models used for our experiments are MobileNet version 2, NASNet Mobile, DenseNet 121, Exception, Inception version 3, Inception ResNet version 2, ResNet 152 version 2. In the individual model architecture, we have used RGB images separately, and RGB images are fed to the CNN models and then to the dense layers, and then classified as fire image and no fire image. The same process is being repeated for the HSV image and the YCBCR image. So these are 3 spectrum of image obtained from the RGB images. RGB images were converted into HSV and then YCBCR. So the performance of individual models is given below as test accuracy. In RGB spectrum, the highest test accuracy was obtained as 94.90 using Inception version 3. HSV gave a highest test accuracy of 87.87 in Inception version 3, and YCBCR gave a highest accuracy of 83.10 in Exception Net. We have a challenge data set too. So in the challenge data set, there are images which creates a confusion of showing clouds, fog, that is being categorized as smoke and fire images, and there are images which appear as like bright red images, bright red clouds, which is categorized as no fire images. So those are images which belong to the challenge set. So in the challenge set, the test accuracy has gone down a little bit. So the RGB images gave a highest test accuracy of 81.92 in Inception ResNet version 2. HSV gave a highest test accuracy of 66.47 using ResNet 152 version 2. And YCBCR gave a highest test challenge accuracy of 61.84 in Exception net. So we decided to combine two spectrums, that is fusion of RGB and HSV and fusion of RGB and YCBCR, to find out how much of improvement we can get in the performance. So RGB image is fed to a deep learning model and RGB features are extracted. Similarly, HSV features are extracted and both the features are concatenated and then fed to the fully connected dense layers, and from there it is being classified into fire image and no fire image. Similarly, RGB images and YCBCR are fed to deep learning models. Corresponding features are extracted, concatenated together, and fed to the dense layers to classify into fire and no fire images. The performance of fusion of two spectrum is as follows. RGB plus HSV fusion gave a highest test accuracy of 90.05 with ResNet 152 version 2, and fusion of RGB plus YCBCR gave a highest test accuracy of 87.28 using ResNet 152 version 2. Same with the challenge set data. Challenge set RGB plus HSV fusion gave 84.53 using Inception ResNet version 2, and fusion of RGB plus YCBCR gave a challenge accuracy of 82.46 using ResNet, Inception ResNet version 2. Since the performance was increasing a little bit, we thought of combining three spectrums together. RGB image, HSV and YCBCR are fed to deep learning models and corresponding features are extracted, concatenated together, and then fed to the dense layers to classify into fire image and no fire image. The performance of the three spectrum fusion gave a better accuracy with a test accuracy of 96.80 using exception model. The second highest was 96.38 using ResNet 152 version 2, and the third highest was 95.94 using DenseNet 121. The challenge set was evaluated and we got a 85.94 challenge accuracy using Inception ResNet version 2. So this is a comparison of the test accuracy and the challenge accuracy with individual models, fusion of two spectrum and fusion of three spectrum. So individual model highest test accuracy was 94.90. When we combined the fusion of two spectrums, it reduced a little bit, but when we combined fusion of three spectrum, it gave an improvement of 96.80. And with the challenge accuracy compared to individual models, fusion of three spectrum gave a better challenge accuracy. Conclusion: automatic fire detection using computer vision based methods is a challenging task due to non-uniform shape, color, and presence of motion. Multispectral deep learning models combining complementary information from various spectrum enhances the performance of fire detection. Future work is developing an end-to-end lightweight fire detection system. Thank you. If there is any questions, I'll take it now. Thank you.
Thanks a lot, Smitha. Do we have any questions in the room? Well, if not, let's thank Smitha again.
Thank you.
And our next talk is from the same university by Sage Wakota. I don't know if it's the same stream or if we're doing with a different call. Okay, so there will be the first talk for the next session.
Thanks for the talk. We have problems with a colleague. He is not answering our emails. We are now rearranging the schedule that we are doing another call first, and he's the next.
Excuse me.
Yes.
Actually, I'll be presenting on behalf of Saideshwar.
Ah, okay. Thanks
Yeah.
for the information. So we hear your next talk. Thank you.
Okay, thank you.
Well, then the floor is yours for the next talk.
Can you see my screen?
Yes. I might interrupt you 3 minutes before the end so to let you know that the time is almost over.
Okay, yeah. So the topic I'm presenting today is multimodal combination of text and image tweet for disaster response assessment. I'll be presenting on behalf of Saideshwar Kota. I am Smita Haridasan. My advisor is Dr. Ajita Ratani. Other team members are Dr. Aaron Bowen, Dr. Glenn Remington, and Dr. Ratri Datta. We work for the Disaster Resilience Analysis Center at Wichita State University. The outline of the presentation is as follows. We start with a brief introduction, and then we'll proceed to the problem statement, proposed method, a brief introduction about the dataset and the experimental results, and conclusion and future work. Starting with the introduction, information related to natural disaster is always posted on social media. Sharing such information is useful for humanitarian support. Example keywords in tweets useful for informative category are caution, help needed, warnings, rescue, donation request. To the right is a sample tweet about an earthquake that happened recently in Dubai. So these are sample tweets which we consider for our experiments. We consider the text as well as the images that come with the social media tweets. This is a sample non-informative tweet. That means that the tweet happened during a disaster and is not useful at all. Seeing the image, it does not help in any of this humanitarian purpose or as a informative tweet regarding a disaster. It says, anyways, I drove through the redwood forest, then next to California wildfires. So such rampant sharing of crisis-related posts has led to the need for categorizing data into informative and non-informative categories. Humanitarian aid workers help people during crisis events to save lives, reduce suffering, and rebuild affected communities. With respect to the prior work, Offley et al. Evaluated VGG16 on tweet text and tweet images from Crisis MMD dataset for two categories, informative versus non-informative and humanitarian categories. So they evaluated text only first, and then they evaluated image only, and then fusion of text and image. So they've given the test accuracies of informative versus non-informative and humanitarian categories. So these are the accuracies given as per the baseline paper we have compared with. So the problem statement we have used is like the aim of this research is to process multimedia data and propose a fusion-based decision-making technique to classify social media data into informative and non-informative category. Informative tweets are then classified into various humanitarian categories such as rescue volunteering or donation efforts, infrastructure or utility damage, affected individuals, other relevant information, and non-humanitarian category. So the dataset we've used is Crisis MMD. Crisis MMD contains tweet texts and images collected during major multiple natural calamities including earthquake, flood, hurricanes and wildfire. The abundance of social media data clearly indicates the possibility of image processing research, mainly by assisting
Sorry
humanitarian
to interrupt.
aid workers.
We lost you for a few minutes, maybe.
Uh,
yes, so we couldn't hear you or see you anymore for some time. So perhaps if you could go back a few slides, we might
Yes.
be able to tell you where we left that off. Yeah, that was it.
This one?
Yeah, I think you can restart here.
Okay. Thank you. This is a sample non-informative tweet. The image shows just a drive-through, just for trees, and it's in the middle of a forest or something. And the tweet says, "Anyways, I drove through the redwood forest, and then next to the California wildfires." This is a tweet that happened during a disaster, and this is in no way related to information that will be suitable for humanitarian aid. So, rampant sharing of crisis related posts has led to the need for categorizing data into informative and non informative categories. Humanitarian aid workers help people during crisis events to save lives, reduce suffering, and rebuild affected communities. With respect to prior work, Offley et al. Evaluated VGG16 on tweet texts and tweet images from Crisis MMD dataset for two categories, informative versus non-informative, and humanitarian categories. So these are the test accuracies obtained using text only, image only, and fusion of text and image. This is the base paper we are following, and then we are comparing our results. Problem statement. Aim of this research is to process multimedia data and propose a fusion-based decision-making technique to classify social media data into informative and non-informative category. Informative tweets are then classified into various humanitarian categories such as rescue volunteering or donation efforts, infrastructure and utility damage, affected individuals, other relevant information, and not humanitarian category. The dataset we have used is Crisis MMD, which consists of tweet texts and images collected during multiple major natural calamities including earthquake, flood, hurricane, and wildfire. The proposed method, we have we have done 3 experiments. The first experiment is with text modality, that is we use only the text tweets. We pre-process the text tweets and then feed it to Distilbert, and the features are extracted. The features are being fed to the dense layers, the corresponding dense layers, and categorized into informative versus non-informative and humanitarian categories. So there are 4 humanitarian categories. The performance of Distilbert is as follows. We've got it 82.65% test accuracy using with informative versus non-informative category, and 75.39% humanitarian categories. With experiment 2, we have used image only modality, and the CNN models used are VGG16, 19, ResNet 50, DenseNet 121, and RegNet Vive 320. The image tweets are pre-processed and fed to corresponding CNN models. Features are extracted and then fed to the dense layers for future classification. After evaluating all of the CNN models listed, we have got a best accuracy of 85.13 with informative versus non-informative category, and 80.20% with humanitarian category. With the experiment 3, we have combined the text tweets and image tweets. So this is a fusion of text and image. The text is being fed to the Distilbert, and features are extracted. Image are being fed to CNN models, and the corresponding features are concatenated together and then fed to the fully connected dense layers, and then classified as informative versus non-informative and the rest of the humanitarian categories. The best informative versus non-informative accuracy we've got is using BERT with RegNet 5, RegNet Y320, that is 89.63, and for humanitarian categories we've got a 86.59%. Here is a comparison we've done for the informative versus non-informative. Text only gave a accuracy of 82.65, image only gave 85.13, and text plus image gave 89.63, which is a 5% increase compared to the base paper. Humanitarian results, with text only we've got a 75.39, image only gave a 80.20, and fusion of text and image gave 86.59, which is a 8.19% increase compared to the base paper. Conclusions. Experimental results suggest that fusion of text and image tweets using multimodal deep learning model on crisis MMD dataset performs better than either the single text or image modality. Future work. As part of future work, we will explore advanced fusion techniques for combining text and image modalities and advanced deep learning models to improve the classification performance. Thank you. Any questions?
Thanks a lot again, Smita. Any questions for Smita on the second presentation? If not, let's thank Smita again.
Thank you.
And this is now a coffee break, I think.
Brauchen wir eigentlich schon gar nicht mehr, oder?
And the first speaker will be Professor Dr. Gerebe, who's an associate professor for the University of Leipzig and is now working in close collaboration with the University of Leipzig and also with INFI. He taught and researched for several years at the university and will give a talk about the semantic-aware metadata and resilience of socio-cultural systems.
Thank you very much. So let's try this, how this works. Okay. 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 I will talk about resilience. The question is, what is resilience? This is a question maybe not yet discussed in this conference in very detail. It is an elusive concept which appeared first in psychology in the 1950s to address questions of the robustness and adaptability of individuals to changing social cultural conditions. And since at least the 1970s, the concept has also been applied to questions of ecosystem adaptability. And in the last 20 years, the concept of an ecosystem, which in which the notion of resilience has been applied also to other social cultural systems, such as technical ecosystems, energy ecosystems, business ecosystems, and others. These are social structures of a large number of independent stakeholders with diverging interests. So this is more or less the definition of what I mean with social cultural system. And the first question arises about resilience. Is resilience management in general only about retaining the inner structure of the system under environmental changes, or must it encompass the possibility of a fundamental, a disruptive reconstruction of the system under such changes in order to ensure its future viability also beyond certain tipping points of the environment? In 2000, Holling proposed a concept of systemic development in which stable development phases alternate with phases of instability and transformation, and the ability to restructure the system depends essentially on the question in which phase neighboring systems are currently in. So if you have an unstable situation, you have stable systems in the neighborhood, things are more easy than if all the systems are getting in an unstable situation at all. Hence, resilience management of systems, and in particular of social cultural systems, is concerned with a systems-environment relationship. And in a systemic view, as developed by Holling, however, the environment is itself systemically so structured, and thus we are faced with a relationship between systems. Now the question arises, what is a system? I cannot go in very detail on this topic here. I restrict myself to formulate several mnemonics. First, a system is a unit which is delimited against an environment. Second, this delimitation takes place under at least three aspects. It is a unit of analysis, making plans and so on. It is a unit of operation, it must be operated, the system. And it is a unit of development. So even if, and the third point is more or less the important point if you think about resilience. Third, a system provides emergent functions that are bound to the interaction of its parts in a systemic whole and cannot be addressed to a single component of the system. So this is more or less the characteristic of a system. And the fourth point is that a system requires a qualitatively and quantitatively determined throughput of material, energy, and information as an operating condition to maintain its inner structure. So if you have not this throughput, you cannot keep the inner structure or change the inner structure in such situations.
a social cultural system as a system of corporate action is important in 2 points. First, it develops its own conceptual world, I call it semantics, oriented towards its functionality. And second, it produces data on this, based on this semantics. In a social-cultural ecosystem, hence, the different conceptual worlds of the system and its subsystems are to be put in relation, and the resilience requirements of the system and those of the subsystems must be distinguished. For this purpose, data recorded in domain-specific semantics of a subsystem must be processed at the level of the overall system and its different semantics. This data has to be prepared and processed in the upper system, and I call such data that are prepared and processed in the upper system metadata, because I found a metadata definition as the structured data containing information about characteristics of other data. The other data are the data in the subsystem, and if you have metadata in the upper system, so it passes more or less in this definition. This metadata is also semantic aware, because semantic aspects are transported from the subsystems into the overall system during this transformation. So this is my motivation why it is called semantic aware. Let's have a closer look at these interrelationships on the example of the scientific publishing ecosystem. The author information maintained by a publishing house or library is semantic aware, metadata, since semantic information about publications from different scholarly communities as subsystems is transferred to this system. Let's explain the differences between the conceptual worlds at both levels with regard to the role of publications in more detail. In the respective scholarly community, the authors as scientists are researching subjects. The publications serve scientific exchange, and the conceptual world of the scholarly community is reflected in the content aspects of the publications. At the level of publishers and libraries, the focus is, among other things, on bibliometric descriptions and measurement procedures, and hence on formal aspects of the authors and the publications. At both systemic levels, digital collections of publications are of interest. For the scholarly community, access to these publications is most important as one of the central issues of resilience. In the last 30 years, the pre-digital practices of preprint distribution have been replaced by practices of digital provision of such preprints. The initiative to build such digital structures came initially also from the different scholarly communities. In the system of publishers and libraries, in addition to producing, making available and managing the publications, the development of access systems to own digital collections of publications is gaining in importance with ongoing digital transformation. Hence, the resilience conditions for this service of publishers and libraries to the different scholarly communities are changing. And with it, the conceptual world used to describe these practices of publishers and libraries. One example of the difference of semantic embeddings is the identification of authors of a publication. While in a narrow context of a special scholarly community, social contacts are sufficient to unambiguously identify authors of papers as real-world subjects, despite different spellings of names, the problem of author disambiguation has long been unsolved at the level of libraries and publishers. To solve that problem, libraries and publishers have originally built up its own internal referencing structures with unique textual representation of authors and so on, which have now been merged into two existing worldwide structures. I think the one is GND, WIAF, and so on, and the other one is more or less becoming the ORCID system as one certain standard in this area. The first one is more supported by libraries, and the other one more supported now, as I think, by publishers. The consolidation of this and other metadata in the system of publishers and libraries allows to design new services that use this metadata as basis for their own data. Examples are performance measures for individual authors, such as the H-index, or the digital extraction of cross-reference structures between different publications. The data, in turn, is playing an increasingly important role at this upper system as semantic-aware metadata in the scholarly communities. It is metadata in the understanding developed here, since not only the data, but also the conceptual ideas about, for example, the meaning of the H-index or impact scores of journals of individual publications or individual publications are adopted in a social, culturally broken way in the conceptual worlds of the different scholarly communities. Hence, we are dealing not so much with a relation between system and upper system, but rather with a relation between neighboring systems. Semantic-aware metadata on authors has been further developed in the system of publishers and libraries into a reference structure that resolves the author disambiguation problem. It is not only a theoretical solution, but it is implemented as social technical practice, and the required infrastructure is operated and maintained. Hence, the solution can and is now also be used in the subsystems of the various scholarly communities. Conclusion, semantic-aware metadata is an important concept to combine semantics in different systemic contexts for semantic-aware management of a domain-specific data collection for cross-domain use. The question to determine more precisely which domain-specific concepts and to what degree of detail are relevant in a cross-domain application can only be answered in a discursive negotiation process between data providers and data users. Only in such an organizational framework of resource management of data stocks, the stable availability of up-to-date data sources can be organized, which in turn forms the basis for not only qualitative but also quantitative change management, and thus provides the semantic means to base resilience management in social-cultural ecosystems on a database-driven and thus scientific foundation. Thank you for your attention.
We've got a quite theoretical dive into the relationship of systems and also into our current publication system. Are there any questions?
Thank you for the talk. I mean, the publication system is a little bit far away from what we try to, or what we observe in the Kuiper project. Do you plan to rethink or apply this theory to supply chains or economic structures in some way? Or what future work do you have in mind with the theory?
This publication ecosystem is a mere example to explain the ideas. I think all of you understand more or less what's really happening there, because to explain semantics means to address something that you understand. The same is about ecosystems, economic ecosystems, more or less supply chains. where you have business units at one point. They have a special own conceptual world that is more or less defined as their business process, models, systems, and so this is more or less nowadays quite elaborated and produces data and so on. And you have the more or less upper level where you have supply chains between them. And the question is what are the conceptual systems on this supply chain level? Most, as I understand, business models look at all these questions from a single enterprise, but supply chain is about the relation between the enterprises in a systemic notion. The answer is there are emergent, the more interesting things are emergent effects that emerge at the level of the interaction of them. And I think this point is not very discussed so far as I understand. There is one area where it is more elaborated already. This is in the energy ecosystem, because the energy ecosystem requires, if you have many decentralized energy providers, you need a strong management of really the interrelations between them due to technical conditions. And I think there we have interesting ideas what question could be or should be posed in such inter-business relations if we subtract the technical points in this direction. So I think the idea to go to these questions with systemic thinking should be very interesting.
Thank you.
Are there any other questions? Thank you very much. And we will continue with a talk by Philipp Ulrich, who's a PhD student at Infineon and also at the Technical University of Munich. And he will give us some insights into challenges for achieving supply chain resilience and transparency within the Kuiper project, which is quite famous today.
Okay, so then, thank you very much for the introduction. So as a bit of background knowledge, I'm Philipp Ulrich, I'm working at Infineon, and I'm mainly leading here the Kuiper project from our side. We are responsible for use case in Work Package 6, also together with Siemens and of course many other partners inside of the Kuiper project. And we are talking today a bit about challenges for achieving our goal of more supply chain resilience as well as more transparency within supply chains. And the talk today will be about these challenges, but I want to also deep dive into one challenge that might be not too familiar to some of you because it's a bit more domain specific. The other ones are a bit more generic. So let's start. The first one is about tactical demand, and this will also be the focus of today's talk. So basically customers reporting demand tactically in supply chains. This is a problem also for the semiconductor industry, but not only for us, also for many other industries as well. We have been seeing that, for example, in the COVID times as well with toilet paper on the private market, right? So this is something that everybody's panic buying and stuff like this. And this leads to a strong bullwhip effect, which I will be covering today in the talk as well. Now, another thing is, of course, the main complexity that we are facing here. We have a lot of cause-effect relationships which are really hard to estimate or evaluate, or even impossible to evaluate here. I always say it's basically about waves clashing with each other, and then you're in the field of fluid dynamics, and it's quite complicated to see what is coming out of it. It's always easier to evaluate something in hindsight, but for crisis and such huge disruption, that's not the case. And of course, we all have complex supply chains. For example, the semiconductor supply chain, we have a lot of process steps, around 1,000 process steps here, and really complicated global production lines. So this is just complex, and we need to somehow capture that in our models with our applications. Another thing is transparency, or the lack of transparency, better said. So In supply chains, of course, you might know, you hopefully know of your direct customers, you know of your direct suppliers, but after that it's quite fast, gets quite blurry. So you don't know about the suppliers maybe 2 steps ahead of you or then also before you and stuff like this. And that's something which of course would help so that you could achieve more resilience in terms of supply and also in terms of demand, but it's not that easy. And also strategically companies won't share that information mostly with us. Then another thing, the heterogeneous crisis, right? So if we compare crises from the past, like the economic crisis, 2010, and as well then the COVID pandemic today, or even now the geopolitical conflicts like the war that we have right now, they are rare and they are not really that well comparable. Each of those crises had like really different impacts on the supply chains for the semiconductor industry, but also globally. Another thing is explainability. The explainability is especially important in the business context because, of course, stakeholders that do not trust any black box decisions, and this is one of the huge things that you have with neural networks and stuff like this. You get a decision out of it, but you cannot really explain it, why this decision is now the case. In the end, the humans will be responsible for whatever decision is taken based on the AI, so therefore explainability would be key to basically make stakeholders trust the decisions in the first place. And the last one, which is also quite generic and might be well known to most of you, is data quality and volume. So, of course, we need to ensure that the data has an appropriate quality for a use case, and we also need to handle the huge amount of data that we will get through different sources, through sensors, and also, of course, economic data and so on and so forth. So today I want to deep dive a bit more into this first one here, because the other ones are quite generic, might be known to most of you. You could do a talk on each of them for 10 minutes, but today we want to focus on the tactical demand side. So this is an image of the semiconductor market, which is compared to the real GDP over time. And what you can see here, first of all, is that you can see both crises here. We can see in 2009, 2010, the economic crisis here, and we can also see how the GDP is going up and down, as well as, of course, also the semiconductor market. But what is interesting here is, if you look at the scales, and I can maybe quickly pull up a laser pointer to show this to you. So if you look on this side here, real GDP is until 12% here. On the right-hand side, the semiconductor index is around 60%. So really, the semiconductor index is much farther in terms of how volatile it is compared to the GDP. So this is just a metric of how the semiconductor market behaves in certain disruptions. And you can see here the same thing in 2020 with the COVID pandemic. Now what you can see is that we had here a really high amount of fluctuation and here a bit of a smaller one. And this is a bit also because of the bullwhip effect, which I will be explaining a bit later on. This was already reduced from around 5 to 2 to 3, but it is still significant because semiconductors have been becoming strategically more important over time. So therefore, bullwhip effect mitigation becomes even more important in today's times. So quickly a look into semiconductor supply chains. What are usual actors here? If we look at a supply chain, automotive as an example, we do have the OEMs, which are the companies producing the cars and reacting to the end market demand signal, and of course also providing the cars. Then we have the tier 1 suppliers. They are basically building components that will be built into the car. And then on the end, we have the semiconductor tier 2. And all of these, of course, are highly connected to each other with the subsequent tiers on a global scale, which is the case for most companies today. Now, this is important because if we look at this graphic here, then we can see the different tiers. So first of all, we can see here the demand of the OEMs, which is this green line here. And you can see it takes a dip here after the COVID pandemic, and then it recovers after some weeks. If you look then around tier 1 here has the same dip, but it goes down even further and goes up a bit more. The same happens if you go down the supply chain to tier 1. And if you are looking at the semiconductor tier, then you can see that this demand is amplified a lot. And that's especially what is the huge problem that we face. The results of this model, this is a simulation model here, show a clear amplification of the demand change in the end market for the light vehicles. And the more upstream you go, the more extreme this result will be visible. And when you're recovering in the end market demand will end up about 40% higher, so double the amplification compared to the tier 2. This means that we basically will produce maybe the wrong amount of products as well, and of course much more what we really would have needed for the actual situation in the market. So this is, for example, then the actual curve that we observed. So this is the simulation model, and this is the actual curve here now that we observed during the pandemic. So now, what are these technical demands that we have been talking about before, and how do they go into the bullwhip effect? So for the bullwhip effect, we do have several bullwhip drivers in supply chains, and a collaboration and communication along the supply chains. This is quite obnoxious here. Collaboration, the communication along the supply chain is quite important for us because it will lead to a better understanding of our current situation. So we want to understand our demand. We also want to understand if the demand is overheating, if it's cooling down, stuff like this. Therefore, precise forecasts are quite important for us in the semiconductor industry because we do have two very important characteristics. First of all, semiconductors have a very long lead time. So if we want to produce a semiconductor, it takes 6 to 9 months. So if you tell me today to produce a semiconductor, I can get back to you, but only in 6 to 9 months with the actual product. And also, we cannot parallelize the production of semiconductors too well because they are built in layers. They're basically etched on layers in the lithography process, and therefore we cannot do that in parallel. Just each step is coming after the other. So therefore, we really want to have good and precise demands early on so that we can basically plan our production quite well. So the problem now comes that companies are strategically not disclosing their true demand to competitors and also to suppliers, right? So there is an interest in not doing so because it's, of course, incentivized by the ordering system. Instead, what they do is they communicate a tactical demand to suppliers, so not really the real demand. Because in the order system, the goal, of course, is to make sure that your own demand will be fulfilled. And if you basically order more, you have a higher chance in the allocation to get some of the needed semiconductors. The result now is that we will get an inflated demand, which will be amplified a lot by the bullwhip effect that we talked about before. And this is, of course, now critical because in the end, we will be ending up with something like this. We can see in this graph here the true demand, which is like the orange line here. Then we have the bias demand, which is basically what we will get as a tactical demand. And in between, we will have a lot of noise, right? And in the end, we have this bias component. This is basically, during the start of the pandemic, we had a lot of order cancellations because the customers ordered more than they needed and then canceled it afterwards. And then after the recovery of demand, we basically were led with higher quantities because of this tactical demand. And then we have, of course, on top of that, the noise. And the noise is then amplified by this bullwhip effect along the supply chain. And this leads in the end now to a hindering of our collaboration, right? So we cannot work with that too well because the competitors do not want to share their true demand data among each other, and we get this noisy and biased data basically, which is not really suitable for AI algorithms, right? Because if your data is not good, then your results also won't be accurate enough. So with better forecasts, we could get to faster demand fulfillment. So I don't want to end this basically with only the problems and all the challenges here. I mean, this is the main reason of this talk, but I also want to propose at least some solutions and solution approaches that we are thinking of. So there are two things that we can do. One is more affiliated with the Koipu project, the other a bit less. So for better demand understanding, we can go on the route of better demand forecasting through marketing demand. So basically trying to capture as much as possible of the other external dependencies in the market and also some other economic factors and stuff like this, what is happening in supply chains based on the graphs, for example, to understand influence factors and demand drivers of customers better. That's basically the Koipu use case that we are doing. And the other side is a bit more in the direction of basically trying to remove the incentive to communicate a tactical demand. And one way on how you could do this is go with an anonymous true demand survey. So basically make sure that everything that is put into the survey is completely anonymous. You cannot trace it back to individual customers, and decouple it from the order system so that you have no incentive of basically giving a tactical demand in the first place. And this can then be used to identify overheating and also smoothing of supply chains, and can be used to better plan semiconductor production, because this is the main reason why we are in the supply chain in the states that we have today with semiconductor supply chains and the chip shortage, basically. So yeah, lastly, where does semantic web come into play? So for us, of course, in Koipu, we are mainly about knowledge graphs. So how do they help now? So for us, they will be helpful most of the time for the complexity management. So semantic web can be used, for example, to break down the high-level forecasts to the needed level. So we can get, for example, from the high structures of semiconductor nodes, for example, 50 nanometer semiconductors or 100 nanometer semiconductors, we can break that down to the products that we're actually selling to get a better overview of our own forecast and what we then need to do for our production lines. As well, we can, of course, provide services based on the enhanced demand on a finer granularity as well. And in the end, what is hugely important, because all of this approach is, of course, communication and collaboration as well along supply chains. We want to have a common understanding across all the supply chain tiers. So you can see this in this graphic here on the bottom. We want to have a collaboration, communication, and as well as more transparency from the supplier, early in the supply chain, to the semiconductor industry, of course, back to the EMSs, which are distributors in the supply chains, of course the tier ones, back to the OEMs. So that's basically the whole goal, to coming to more collaboration and also mitigating the bullwhip effect in the end and getting rid a bit of these tactical demands that have been basically impacting the semiconductor supply chains worldwide now. Okay, that's it from my side. Thank you very much.
Thank you very much for the interesting insights into semiconductor supply chains and problems and demands. I see already one question.
Yeah, thank you very much. Very interesting talk. But I was thinking a bit, the problem you have here is on the one hand a resource allocation problem, right? And on the other hand, you have information asymmetries. So some people there know more what they don't want to share with others. And I think in economy, there is the theory of prediction markets, that they are actually solving exactly this problem. When you have these information asymmetries and resource allocation, prediction market basically is the stock market, for example, or auction models. Are there also such models in place that you organize some auctions, for example, to so that customers have to commit some resources, some financial resources, for example, to get certain guarantees for delivery?
Very good question. For our model, we do have, for example, lead time-based pricing for that, which goes in, I would say, in a similar direction, right? For lead time-based pricing, it's basically about you pay more. You know this all from the flight industry, right? If you want to have a flight, you want to fly tomorrow, it will get expensive, right? You can still get your flight, but it will be really, really expensive for you. If you know of your flight several months ahead of time, then you will get your flight more cheaply. Same way can also be applied to the semiconductor industry with lead time-based pricing. If you know your semiconductor demand, like I want to have it in 2 weeks or whatever, then you pay a lot more than what you would pay if you know it a lot in advance and also quite accurately. So this, I would say, goes into this direction, yes. Some other models, we are also considering them, and I also would like to look a bit more into those in detail then afterwards. But these are like the first steps into an approach to basically mitigating the chip shortage sustainably, right? Because we don't want to run into the same problems afterwards as well. But thanks for the question.
Are there any other questions?
Your use case is full of contradictions. Did you, or how far did you apply contradiction-oriented methods to solve these problems?
First of all, what kind of contradictions?
I think you had many of them. The contradiction between the behavior of Tier 1 people and Tier 2 contradictions. Similar in the direction as Sean said. And my question is, there are contradiction-oriented methodologies that say, okay, we have contradictions, we should apply those and those methods and classify the contradiction. So your question is part of my question, more or less.
So you mean basically contradictions in terms of information that is shared between tiers, right? So contradictions between the true demand, the tactical demand, stuff like this, right? That's the intent.
Also between interests of the parties, also contradictions on a business level.
Yeah, we're not applying this as of right now, but I think it's quite interesting. We will look into it for sure to see whether this could help us with our research. Yeah, thanks.
Are there any more questions? Maybe I got the last one. I saw on one of the slides that you said that you got pretty noisy data, and it's hard to train AIs on this noisy data. As far as I know, AIs are pretty good at ignoring noise when they are trained. So could you elaborate a bit on the topic?
Yeah, so the problem is more in the direction of if you're now looking backwards, right, at your forecast that you get from the past. You look at the actual orders that the customer have placed and then in the end also realized, so paid you for, right? This is, of course, the the true demand, what they really needed in the end, what they really wanted to have in terms of semiconductors. This is what we initially, or like ideally, then also produce, right? The noise I'm talking about here now is basically a combination, of course, I can also go back to the slide maybe here. The noise here is basically the bias that we get from this tactical demand. So basically, the customer not telling us exactly what he needs, first of all, because there's a tactical incentive of not doing so, which is just a psychological thing. You cannot change that, really. You can try to mitigate it by, for example, removing the incentive. And second of all, if you have the noise here, is now meant by that there's this bias from the tactical demands, and this is then amplified by the bullwhip effect. And the problem is, with these huge disruptions, you won't notice for certain how much of this is now noise, right? Because for the COVID pandemic and for the economic crisis, it will be totally different, right? If you have, of course, like in usual business times, then you're right. It would be, we could, of course, benchmark then what we actually had as orders in the system, and then look back and say, okay, in usual times, we have this amount of noise always in our data, we can calculate this out, that's fine. But if you have disruptions, and that's the main problem now here, we are living in those times of disruptions, then it's not really possible, right? Because you cannot estimate this noise, there hasn't been something like this before, and stuff like this, right? So that's, I think, an elaboration which should help to understand.
Okay, thank you very much.
Yeah, thank you for the questions.
So our last talk will be from Dr. Felix Engel, who's working at the Technical Information Bibliography in Hanover. He's a project manager and terminology service coordinator, and also member of the Data Archive and Ingestion Working Group. And he will give us some insights into challenges in the creation and uptake of ontologies. And he's joining from remote today.
So I hope that you can hear me. Okay, I have an echo, so I guess you hear me. I will speak against my echo. Hope. That's better. Thanks. Okay, great. Okay, so many thanks, Philip. That was a wonderful basis for actually what I would like to present here. So I would like to speak a bit about challenges in the creation and uptake of ontologies. And right, and this topic is embedded in research results from two projects, the SC3 project and the KOIPU project, the famous KOI project. And as agenda points, I will first motivate a bit the work and then introduce some solutions that we provide as outcome of the two projects. So first of all, so what Philip said is that a very important aspect in resilience is collaboration and communication, and that is as well a basis to make an informed decision that helps to make your undertaking or your business more resilient, right? So, and as a basis for that, you need data. You need data, and data in a sense is kind of unorganized facts, as in the first instance, as for instance those data sensor streams that we have heard about this morning. Next up, when we process those data, we have information. But however, if we have the information, so a little bit up in the value chain, let's say, we have the huge challenge that we need to prepare that data for communication, because in supply chains, we have a lot of stakeholders and a lot of involved participants that may use different languages, have a different understanding about concepts, and so forth. And within KOIPU and SC3 project, we make use of ontologies to build an unambiguous communication framework, exactly to address these issues, to provide kind of a formal and shared description of the knowledge that we exchange. And I'm not sure if the KOIPU project is introduced in one of the talks. It was mentioned quite often. Actually, its full name is Cognitive Economy Intelligence Platform for the Resilience in Economic Ecosystems. And we work, well, one part of this project works on an ontology, the COI ontology, which essentially is an upper and domain-specific set of ontologies to formalize crisis-relevant events and contextual informations, let's say. Beside that, in the SC3 project, which is a commission-funded project, its full title is Semantically Connected Semiconductor Supply Chains. We are working for same reasons on the digital reference ontology, which essentially models supply chains. Yes, I can switch to full screen. Actually, I tried it, but did not really. Ah, yes. I think it's now on the wrong monitor, right? I can't hear you.
Currently see the presenter's view. Yes, that's the wrong one.
That's the wrong one. Okay. Okay. So I stop sharing. Put it here and then. Better?
Nope, it's still the same one.
No. So it one two stays there. Okay, I just make it a little bit bigger. Okay, and sorry for that. Okay, that might be helpful. Okay. Can you mute your mic because I have an echo again? Okay, thanks. Okay. So, well, we work on ontologies in the in both projects, and now there are several challenges in the work on ontologies, and I want to elaborate specifically on two of them. The first one, I want to mention them just to mention them all, is that ontologies are domain specific to the engineering, cultural, chemistry, whatever domain, and they have a different understanding of concepts. And not enough, within community software domains, they will have as well a different understanding of concepts and so forth. Second, our language and understanding evolves continuously, and this is a process that potentially will never stops. And third, if we work on ontologies as a communication framework, we need to bring them into the community so that they are accepted, developed and maintained from the community, even after a project funding frame, right? And to avoid to work on isolated solutions. So we should reuse as much as possible of existing ontology and knowledge that is out there to find a shared understanding. And fourth, if we work collaboratively on ontologies, we need tools to communicate between the various stakeholders that are involved in the ontology creation. First, the third issue is addressed in some solutions that we are working in the scope of the COIPU project and other projects as well. That is the terminology service, and we are working on cross-stakeholder visualization, which addresses the issue 4 in the SC3 project. Okay. So what is the terminology service? Essentially, it is a web-based platform used for ontology take-up and standardization. And we have released a first MVP last year. And we have about kind of more than 100 ontologies in that service. Well, as you may expect, it's not only our COIPU related ontologies. We have a huge variety from chemistry, engineering, and so forth. So we have in total 8 collections that we have ontology, that we manage ontologies for. And as a functional service offer, we provide free text search within and for ontologies. We provide functionalities for browsing, filtering, visualizing ontologies, an issue tracker to communicate, to get in contact with the community. And we provide a REST interface for accessing those ontologies and use them in third-party applications. Here is a snapshot of the collection, of the Koipu collection. We have by now only 6 ontologies in it that we use in our Koi ontology. And but this list is continuously growing for sure. And we are working on a tool to calculate mappings between ontologies, as you can see on the right-hand side, which is actually work in progress. But we can calculate similarities to see to which other domains and ontologies we are very close with, and that we should get in contact to collaborate and reuse their work as well. Another work in progress is that we integrate Web Protégé into the terminology service, so that we are able to collaboratively work on the extension and creation of ontologies. And we work on a GitHub extension to Web Protégé so that we have a simple access to the ontology management tool, let's say. But this is a work in progress. We made some big steps forward, but there are still some issues to solve. A bit aside notice, we did as well have some work on Firefox plugin. Actually, Firefox, but could be for Chrome and else developed as well. That is used to get definitions from a text that you mark in a web page. As for instance, here I have marked the word event in a Wikipedia page, and then I could search for definitions from the ontology. Here I've searched for our Koipu definition in our Koi ontology. So this is a quite handy tool to make use of the ontologies. So now going back to the collaborative work and to the aspects that an ontology is created by knowledge engineers on the one hand side, who have the knowledge about the domain to be modeled. The domain expert with which have the knowledge of the domain that we want to model, and the knowledge engineers that have the knowledge to, well, to build the ontology. And between, especially between those two, we need a kind of communication tools that process the information in such a way that both sides are hopefully able to understand what the other is talking about. And actually, we did it on visualization tools to bring ontologies on various levels in a presentable format. As a basis for this, Vitalis Wiens has introduced the so-called resource relation model, which every ontology could be preprocessed to, and this model serves as the basis for various kind of visualization. And actually, we provide 3 visualization that based on this model. That is the hybrid view, the textual view, and the graph-based view. And here are some snapshots. I think textual, that's self-explanatory. And then we have a hybrid view of visualization, which essentially shows it's kind of a mixture of the textual representation and visual presentation of the concepts and their relationship. relationships. So we could interactively click through all the concepts and the properties of an ontology, have a look how they are interconnected, which axioms or annotations they have, and so forth. And we see some prefixes and metadata. So this is kind of for the experts and intermediate users. And then we have a graph-based view that we could think of that this is quite handy for rather novice users, so that they see how the single concepts are interrelated in the whole graph together. This view is a web file notation, and it allows you to color specific characteristics of the graph, to highlight them, to navigate in there, and so forth. And last but not least, we have a collection management or a project management tool. So we have in here the SC3 project and the Koipu project, and ontologies that we are actually working at, and then we can go into those ontologies and work collaboratively with our partners on them. Yeah, to sum up, the work on ontology is a challenging task. It requires cross stakeholders involvement. Complementary knowledge must be brought together. And in the Koipu and SC3 project, we do some research on tools to address these issues. That's it. Many thanks, and I'm open for questions.
Thank you very much, Dr. Engel, for your interesting insights into TIB tools and also workflows. I see already one hand.
Hi, Felix. Sebastian speaking.
Hi. Hi, Sebastian.
So on one slide you mentioned the service that you compare new concept to existing concepts in your database. Can you explain more what your plans are, and also, yeah.
So you meant this one here, right?
Yes, exactly. This.
Okay. Actually, our first idea was that we need a tool, a mean to compare ontologies that we manage in our system, to get further ontologies for reuse. So search for similar ontologies, right? And because we actually see that many concepts are reused across domains. So what we thought about is that we, in the first instance, calculate overlaps of concepts throughout ontologies, and not only concepts, but imported namespaces, classes, and so forth, as you can see here, right? What you see is already implemented. So on this very simple basis, we are able to extract all similar or same URIs, compare them as an overlap throughout ontologies, and calculate the percentage of overlaps between the simple between sets of ontologies or pairwise ontologies. And we even have a functionality that compares this kind of similarity to an external whatever ontology.
Thank you.
Yeah, welcome.
Any other questions in the audience?
Hi, do you have a tool to exactly investigate the difference between two versions of the same ontology?
No, but versioning is one topic very, very high on our list that we are working on. Actually, it is a really complex topic as we see. But important to address. I see an urgent need to do so because we need to provide stability, right? Stable versions of ontology for those that really access and make use of our ontologies. So versioning is one of the very important things that we will work on very soon. And but we don't have any tools to compare and to provide information by now.
Thank you.
Hello, Felix. I
Hi.
have a question from Nathanael. He lost his voice during the day, unfortunately. But
Yes.
he's asking, have you evaluated to use the Quid Store to integrate web protege with GitHub?
Yes, yes. I've asked him, and he sent me his GitLab link or GitHub link, so I had a look at it. That is very interesting and it's kind of similar to what we are doing. However, it is what we actually facing problems with is the real integration into Web Protege, because Web Protege in its stable version has a very outdated old technology, and they are working on new Dockerized and super fancy things, but they are changing every week and days and so forth. So there is no stability. Actually, we decided to do our work on the most stable, so version, the last version that they host as well for all the users they have.
Is there a last question available? Doesn't seem so. So thank you very much for your talk, Dr. Engel.
Welcome.
And I will hand over to Dr. Sabine Gröndorf-Haarer for some last words for the D2 Auto workshop today.
Thank you very much. So finally, it's my turn to leave you all with a few closing words and warm hugs. So thank you, all of you who have been here, for your participation. It was every one of you who made it such an enjoyable and interesting event. I think the variety of topics today was extremely wide, but this is just reflecting the structure of this field we are working in. So this crisis management, resilience, research is such a topic, extremely challenging, extremely variable in topics and aspects. For instance, we had talks on a very deep technical level for approaches and tools that are necessary to implement solutions. We had talks that were on a very close use case level, presenting us the questions and the demands of different domains. Then we had talks of deep theoretical aspects. Let me remind you of the definition of crisis or of systems that change, legal aspects that have to be taken in consideration no matter what type of solution we are striving for. So this should explain why it's so interesting for all of us to work in this field, but also why it's so challenging. I think this is reflected by our daily enthusiasm, but also our daily labor. We, as the organizers of this workshop, take it as a confirmation why it's so important to have this kind of event, trying to bring together all stakeholders and everyone contributing to this field. Because only if we are meeting, if we are trying to listen to each other and understand the aspects even beyond the horizon of our own expertises, only if we do this and try to do this, we'll have a chance to come up with an appropriate solution. So this workshop was held for the first time. It's a little seed we planted today, but we are hoping to make it a regular event. So for the next year, we are planning to apply for one of the bigger semantic web conferences, and you all are invited already. So with a good amount of self-confidence, I say, see you all next year at the International Semantic Lab Conference. Thank you.